University News Bureau. The email said, "Oh, just letting you know, there's a great opportunity coming up from the National Association of Science Writers for the Peggy Gershman Idea Grant. The deadline's in a week." Oh boy. So a group of faculty and staff here at Illinois scrambled to apply for that grant. We were led by Diana, and to our delight, the application was successful. The money was to support a professional development workshop for public information officers and science journalists to help those of us to better understand and evaluate the scientific studies that we write about. The workshop is also for scientists who care about the quality of their work and hope to improve their own science communication efforts. And here we are. In this workshop, we plan to learn from one another. There are nearly 230 people here today. Some of us work as communications professionals, some are faculty members, some are journalists, many are graduate students. And each of you has something to share, and we hope you will do that and find like-minded people with which to share it over these 2 days. The sessions are being streamed live. They're being recorded. They'll be available later for follow-up to use however you might to further your communication efforts. That is also the goal of the NASW grant, that this won't be a one-off conference, but this will help inform people in the days to come. So adding to that grant money came money from all around our campus as a testimony to Illinois' commitment to inclusive and authentic science research. The sponsors are listed in the program on the website, and they'll be on the slideshow as the day goes by. Some of the people who helped write that initial grant are speaking to you today and tomorrow. Others remain in essential background roles. And Diana Yates, who's been the central organizer of this workshop, stays in the background. But thank you, Diana. We have just a few directions for you. Yes, thank you. We have just a few directions for you. The primary one is let's treat each other with respect. Science communication is hard work. We are always learning. We come at it from different positions. We hold each other accountable, both within our professions and across the boundaries of our professions. We need each other for research, for sourcing, for distribution, for publicity, and we have something profound in common: curiosity about the world. We plan to keep to our schedule. A timekeeper will flag the speakers when their time is running short. Be looking for that, presenters. And when the workshop is over, we'll email you a survey. We hope you'll fill out the survey, answer it honestly, and return it back. We want to gauge your interest in future events like this. So please look for the survey in your inbox. Presenters, the timekeepers will let you know when you have 10 minutes to wrap up, then 5, and then 1. That includes the question and answer time, which you presenters will be in charge of. So let me introduce our first speaker. Rashid Bashir aims to alleviate maladies such as sepsis and cancer. He also is the dean of what the University of Illinois now calls the Granger College of Engineering. Rashid Bashir works at the interface of biology and engineering. He hopes to solve medical problems. He applies semiconductor fabrication to cellular systems. He has published more than 240 articles and holds 45 patents. His innovations have led to 3 startup companies. Rashid came to the University of Illinois faculty in 2007 from Purdue. He has served as a professor of electrical and computer engineering and bioengineering. Most recently, he was executive associate dean and chief diversity officer of the Carle, Illinois College of Medicine. He also co-led the formation of an alliance with Mayo Clinic around individualized medicine, cancer, and computational genomics. I could go on explaining his many accomplishments. However, he is here today with remarks titled, First, Reduce the Noise. So please meet Dean Rashid Bashir.
morning. Good morning. Thank you all for being here. I really appreciate it. This is a great event, and I want to thank Jennifer and Diane and all the others that helped organize this wonderful event. And thank you for the invitation to me to just come and provide some brief remarks. So I'm the Dean of Engineering at UIUC. I'm just humbled and honored to be in that position. I couldn't have imagined this about 10 years ago, so you just never know where life will take you. Always be open to what comes your way. It's just been an amazing experience. I'm still drinking from the fire hose, as you would say, but every day I'm more excited than the day before. So we'll see where it leads to. As was briefly mentioned, we are also, actually next week, we are going to have our Board of Trustees vote for having our college named. So this is a big milestone for our campus and for our college. And again, it's just, I want to just talk about that just for a couple of minutes, sort of signifies the relationship that we have with some of our alums. So William Wallace Granger graduated 100 years ago from our college. So he graduated in 1919, so this marks the 100th year anniversary for his undergraduate education. And I think it's also a testament of sort of the values of our university in building relationships. So for 100 years, he has kept a relationship with us and his foundation and his family, and so did we. So it's just the amount of trust and confidence that someone has in you for over that long, and I think it's a call for us to really step up and continue the trajectory that our campus and our College of Engineering, that I'm very proud of, has accomplished. So this is a big milestone for us, and actually this week, later this week, the name will be hopefully official. So I just wanted to make a couple of remarks around reduce the noise first around this signal to noise ratio. Of course, I'm trained as an electrical engineer, so when I saw the title first, I said, oh great, I can bring some slides and show some data. I said, no, this is a little bit different, so great, even better. So welcome to Amplify the Signal, a workshop that focuses on the relationship between science and communication about science, and how limitations of one almost certainly can compromise the other. So it's really, really important to keep both of those, of course, in mind. We do great science, and I think we have to continue to do great science communication. And I'm a very big proponent of that. I've worked with many of my graduate students to see how we can do that in a much better way and a much more institutionalized way. So one of the things I would urge all of us to think about is that how do we train the next generation of scientists to do better science communication also. At the outset, I want to stress that the processes of science and science communication are not easy. And I think all of you know that. If we are really think deeply, and if we are honest with ourselves and we are conscientious, we will always struggle to do better science, which means developing better study designs, better statistical methods, clear understanding and reporting of the limitations of our methods, and finding ways to increase the reliability and the credibility of our work. So this is really important as we do science. And actually on that front, many science journals now require like the raw data to even be submitted along with the journal articles to make sure that the conclusions that are derived by the authors can also be derived by any reader of that paper. So there's really a lot more sort of rigor that is expected from many of the top journals as we move forward. And the same is true for writing or talking about or illustrating about new scientific finding. We can always do better, so we got to keep improving and work towards doing that better. And again, to be honest, no one is an expert in doing science per se. We all learn along the way, the scientists, and we continue to approach doing that better and better. And the same thing goes with talking or writing about science. So please keep this in mind as you listen to the presentations here today and tomorrow. These sessions will be interactive, and this means we want you to speak up. We absolutely want you to communicate. This is about science communication, so please communicate, please speak up, and tell the speakers and tell us what you don't understand or what you really like how it was presented, and share your concerns, and more importantly, challenge us. I think we all grow just a little bit, and we can grow a lot if we respectfully and positively keep challenging each other and working together. And again, the most important part of this process is talking, critiquing, exploring together in a spirit of openness and support, in a spirit of expansion of the knowledge that we are all here to expand. This is a self and a co-education process, and it's not clearly a punitive exercise in condemnation. So I think the idea is this is really all about growing together. So we'll be kind to each other, we'll be supportive, but please ask the questions that you have. Tell us if when, or how, we are leaving you behind in some way, and what we can do better. So this is just really, really important. Now, let me briefly also speak about the relationship between amplification and noise. And this is something, like I said, I can relate very well to as an engineer also. We often focus on the amplify part. We think that just saying things louder is better. But that is not the case, and that is not always the case. And we forget about the noise piece. So clearly the goal is to increase the signal to noise ratio. So you want to amplify the signal, but you also want to reduce the noise. And that's just really, really important to also think about this in this context of science communication. And potentially even in this day and age of fake news, and when you really need to also try to understand what is real and what is not real. So if, as scientists, for example, we're giving our non-scientist audience too many details about our methods, we are trying to explain every step and every nuance of the research. We're actually really swamping out our own signal, I think, in that case, right? So I think that you really understand the audience, understand the customers, and not that they cannot understand, it's just that everybody has limited time and a limited scope in terms of when they read the science communication. So I think understanding that is really, really important, and reducing that noise is sometimes more important than amplifying the signal, actually. So if as scientists, for example, like I said, we're giving, again, too much details, I think, if we use a lot of jargon, if we use a lot of specifics that might not be important in getting the core message out, then I think we're really just sort of generating noise also. We're amplifying the noise also, which we shouldn't do. So if, as public information officers, we are sending out every news release we write, whether it's about honors or grants or new scientific findings, this is one of our challenges, I think, that I struggle with when I, now in my position, talk to our director of communications. We have a lot of great things going on, and so how do you pick and choose? What do you really send out to more people, and how do you decide what's really important? Because again, getting a lot of news out sometimes is not the best thing either. And of course, we always have to balance that with, we also talk about how, with our Midwest philosophies and values, sometimes we don't talk enough about what we do. So I think balancing all of this out is really, really important to see how we can do this better. So when we send that out to an enormous list of science writers and institutions and stakeholders, are we annoying people a lot? So I think really understanding that and balancing that, and somehow using technologies and assessments and feedback to gauge that is something that I think is also really, really important. And there is another kind of noise as well. It has to do with how we communicate. If we don't tell our readers about the limitation of our studies up front, we also lose their confidence in us. That's really important, is to build that credibility. And of course, in the practice of science itself, and in terms of communicating that also. That's really important to build that. And our institution, clearly there's no question, has a tremendous reputation and tremendous respect of the readers, but it's something that we need to keep in mind. So if we make it seem as if every single new finding is the most definitive word on a subject, say whether it's something about nutritional supplements or something about a new invention in autonomy, it's something that we need to really just be cautious of that and careful with that. And are we adding to the noise and confusion on the subject, or are we clarifying? So we need to always be clarifying and not muddying the waters. So as you listen to today's and tomorrow's sessions, and you think about how to craft your stories about science, these are some of the complexities I think that are really, really important. And please just think just as much about what you can, what you could delete, what can you refrain from communicating, and with the words you choose. So I think these both things are important. Again, amplifying the signal and also reducing the noise. So keeping that in mind and thinking about that deeply, it's really, really important. And I think this will hopefully make our signal stronger. And the signal to noise ratio should be really high. That's what you really want. So with that, I wish you a great day. Thank you for being here. This is a very exciting time for our campus. There's wonderful things going on as we also launched, as you know, our 150th year celebration last year or so, and then the new strategic plan for the next 150 years. So I think our campus is just at a tremendous time of impact, and I think at the end of the day, that's what we're here. I fundamentally strongly believe in the value of the excellence and impact that is everywhere embedded on our campus, and how we only live once, so we have to make the world a better place and improve the human condition using the science we are doing. And then we do that also, of course, by then communicating and educating what we're doing to the public. That is so important. So thank you for doing this very important work and helping us having this great discussion. Thank you very much.
Thank you, Dean Bashir. Next up is Daniel Simons. Dan is a professor of psychology at Illinois. You may know him as the co-author of The Invisible Gorilla. That book points out that we can fail to notice large changes to scenes, even when a person in a gorilla suit walks through a basketball drill. Dan works to improve the reproducibility of scientific research. He is the founding editor of the journal called Advances in Methods and Practices in Psychological Science. That is published by the Association for Psychological Science. Dan has reached broad audiences through media outlets such as the Washington Post and the New York Times. Today, he will explain how and why to evaluate study design. He'll challenge us to ask, before we amplify the research, what could this study tell us? Please welcome Professor Daniel Simons.
So, as scientists and science writers and journalists, everybody in this room shares a couple of common goals. We want our writing to be read, and we want to get it right. And I'm assuming by the fact that you're here, you're interested in both of those. Amplifying the signal means knowing what counts as signal and what counts as noise. And if your goal is only to get read, then you might as well go for clickbait, because that will get you read. If your goal is also to get it right, the task is a lot harder. And it's a lot harder because you need to question the assumptions about what counts as credible evidence. And that's something that not all of us have had training in doing. So if you are a science writer, you have a background in some science, you might have to write about a wide range of sciences, and understanding what counts as evidence within those fields can be a real challenge. Over the course of this workshop, you're going to hear about cases in which the goals of getting it right and getting it read come into conflict. People will go for clicks rather than accuracy. And you might hear a bit more about that later this morning in cases in which people have made errors in their work and had their papers taken back, or deliberately made errors in their work and had their papers retracted. You'll also learn about red flags that should give you pause about a finding based on the results. You'll get some guidance about plausible and implausible claims and how to evaluate them. And you'll hear tips for making science communication more compelling. The broad goal of this workshop is to learn some tricks that will help you as a press information officer or a science writer or a scientist or a journalist avoid promoting claims that lack evidence, and to figure out which ones are worth promoting. That's the big challenge, as Dr. Bashir was just noting. How do you amplify the right things and not the wrong things? Some of the skills will help you promote that signal when it's strong, as opposed to when it's weak. And today, I want to give some tips on thinking carefully about what signal a study could provide, given how it was designed, and why that's often at odds with what scientists claim in their papers. So I want to start with a fairly well-known example. This is a photo from Science magazine from a story that they wrote featuring an article that was published in the Proceedings of the National Academy. The headline of this story accompanying this picture was "Air Rage, Blame the First Class Cabin." How many of you heard about this story a couple of years ago? Actually, that's surprising, because it was in pretty much every major media outlet. It was covered extensively, right? The core finding was, as reported in the paper and in this Science magazine article, flights with a first-class section were nearly 4 times more likely to have air rage incidents in their economy class. Now, this is an important claim, if true, and it needs to be broken down a little bit. What does it mean to have 4 times more likely to have air rage incidents in their economy class? Well, that could be a really boring answer, right? Economy has a lot more seats. Probably has about 4 or 5 times as many seats. So it wouldn't be surprising at all if the absolute number of incidents was greater in economy than in first class. It'd be a little weird if it were flights with a first class section only that had that higher rate. But those are also the bigger planes, which have bigger economy sections, which are longer flights. So it's not surprising at some level that the absolute numbers would be bigger. That's not what the paper was claiming. It was much more sophisticated than that, right? That would be kind of a dumb claim that would be obviously, yeah, if you've got more people in a room, then you can say that that room has more people in it. That's not the interesting point. What they did was analyzed controlling for things like the number of seats on the plane and the length of the flight, the distance that the flight traveled. And what they looked at was when people boarded the plane in the front and had to walk through the first class section versus when they boarded more in the middle of the plane behind the first class section and went straight into the economy section. How many of you flew to get here today? Okay. How many of you had a plane that had a middle boarding section to get here today? Nobody, of course, because we don't have big planes here, right? So the planes that do that are generally international, long flights, or cross-country flights that are 747s or that sort of large-scale plane. So this analysis was of airline data from an undisclosed airline. We still don't know which airline it actually was. And what they found was that if you control for a lot of factors like how many seats there are and how far the plane is going, you find this relationship that when people board and have to pass through first class, you get a higher rate of air rage incidents in the economy class. But there are problems. So this paper, the proposed mechanism was that walking through the first class amplified aggression by highlighting disparities. Right? You walk through past all the rich people in first class, and you have to get to your economy seat, and you see everybody getting wine and having a little meal and having a towel brought to them. And that aggravates the disparities between the economy and the first class, leading to greater aggression, more frustration. There was tons of media coverage of this study, and it was challenged almost immediately. The study, when you look at it more closely, is a lot of statistical noise that you have to deal with. If you don't control for anything, if you don't control for any of the other variables, it turns out that passing through first class is negatively related to air rage incidents. So the raw correlation between having to pass through first class and air rage is negative. It goes in the opposite direction of this claim. Only after controlling for lots of other factors do you get the positive relationship that they report in this paper. And they also didn't control for some of the things they probably should have. So they controlled for the duration of the flight, and they controlled for the number of passengers, but they controlled for them separately. And those two things tend to be highly correlated. Longer flights tend to have more passengers. So if you control for them separately and you don't look at the interaction between them, you're not going to get the right answer from your statistical controls. Whenever you get a reversal like this, where the pattern, when you just look at the raw correlation, is in one direction, and then when you control for lots of things, it goes in the opposite direction, is quite commonly a statistical artifact known as suppression. It should make you question the results. So how did this sort of paper make it into one of the top journals in our field? There are lots of reasons. And I think a brief digression to another story about airplanes will actually help make it clearer why this can happen. And I'm not faulting anybody involved in this. This sort of thing happens. This is a very difficult sort of problem to analyze. It's got a lot of data behind it. It's unclear exactly how and which factors to control for. And what that means is that depending on which ones you control for, you find different patterns of results. The issue here is that it wasn't reported that way. It was reported as clear definitive evidence that passing through first class induces air rage. It's a causal claim about the mechanism based on the data. So, brief digression into another story about airplanes. Some of you may be familiar with this one. This is a B-17 bomber. This was the most heavily used American bomber during World War II, mostly flying over Europe. It was really effective because these were really tough planes. They stood up to a lot. They could travel really long distances. They could carry heavy payloads. And B-17s typically would fly in formation, so you can see kind of a row of B-17s flying together, and there's a lot of other schmutz all over the screen. That's anti-aircraft fire and flak that enemy forces would throw into the air when they saw a phalanx of these planes coming in, and the planes would take a tremendous amount of damage. In one day in 1943, out of 291 B-17s, 77 were destroyed and only 33 were completely undamaged when they returned. So this is a problem, and this is a problem that the military faced. How can they make the rate of return for these planes higher? How can they reinforce these planes so that they won't get damaged at these tremendous rates? So what they did was called in a statistician. This is Abraham Wald. If you are in economics or do anything related to this, you've probably run across some of his statistical techniques. They're still in use. He was a statistical prodigy. Yeah, they do exist. And fled Europe to the United States in the 1930s. He analyzed the damage to the planes. And the critical question was, is the damage random? Is the damage to these planes random? When they come back, you look at all the damage. If it's random, there's not much you can do. Right? If it's systematic, you might be able to reinforce the planes in a way that will help increase the rate of return. If it's random, you could think, oh, well, I'll just reinforce the entire plane, make the entire thing out of that black box material that somehow seems to survive any accident. But you couldn't do that because it would make the plane that much heavier, which means you'd have to carry more fuel, which means you could travel less distance and carry less ordnance. So you need to be able to selectively reinforce some parts of the plane and not others. So he took a look at the data and all of these planes that were damaged and said, okay, given the area of a part of the plane, was it hit more than you would expect relative to the size of that part of the plane? Just to give you some idea, here's a plane that came back. These planes were tough. They could survive quite a bit. He looked at the data, and it turned out it was not random, that the planes were damaged more often on the extremities and the fuselage. So you might think, okay, great. Let's reinforce the extremities and the fuselage. If that's what you thought to do, that is exactly the wrong thing to do. Anybody know why that's exactly the wrong thing to do? Yeah. That's right. You're looking at the planes that were damaged but made it back. And they were damaged more on the fuselage and the extremities. So if they made it back, then those areas presumably weren't absolutely critical to the plane's survival. If you wanted to do this, and you can't be sure that this would work, but the best solution would be to reinforce any area of the planes that came back that was not damaged at all. Because presumably the planes that didn't come back were hit in other areas, the areas that weren't damaged on the ones that did come back. This is a mistake that we all make when we think about evidence. We tend to think about the evidence that's right in front of us, the information that we have, the ideas that we have, the theory that we have in mind, and not the evidence that we're lacking. Science is about thinking about control. So all of scientific reasoning is about thinking about the appropriate baseline, thinking about the evidence that we're not looking at, thinking about the conditions that we're missing. But we're also human, and as humans, we look at the evidence right in front of us and form patterns from it. That means if we have a strong theory, a theory that we've been working from for a long time, we're going to see the evidence that's consistent with that theory, and we're not going to see or think about the evidence that's inconsistent with that theory. If we run an analysis and it shows that our result is consistent with our ideas, we might not think to check whether that's the right analysis or whether other analyses show that too. If we run analysis that's inconsistent with our ideas, we'll probably keep running analyses until we find one that's not. That's a human trait. It's something that we all do, And I think it comes into play for the air rage study as well. So after this study came out, there were a number of statistical critiques. Prominent bloggers wrote about it. There was also a critique from an airline journalist, somebody who documents trends in the airline industry, who had a lot of questions about the study from an airline perspective, one of which being she couldn't figure out which airline it could possibly have been because none of them had the right kinds of planes to match up. And the data are proprietary, so it's not possible to get information about the details of the planes. You had to work with the abstractions that were in the article. But after the study came out, this journalist asked the editor of the journal, or the editor of that article, Susan Fisk, who reviewed it. And her response was, it was reviewed by experts in aggressive inclinations in face-to-face settings, the psychology of inequality, egocentrism and narcissism, and the socially situated self-concept. All of the things that were directly relevant to the theory, the causal theory that the authors were writing. So if you want to evaluate the theoretical claims, that absolutely makes sense. If you want to evaluate the statistical claims, it doesn't. So why would you go to these sorts of reviewers and not other reviewers? Is that a failure to see past what you want to see? This is a neat idea, the idea that somehow just the experience of walking through first class makes you more aggressive is an idea that has a lot of theoretical force. There are a lot of theories that would push for that idea, and it makes sense to evaluate that theory. But it also makes sense to evaluate that evidence. The study was big news because it was a compelling story, and it fit with what we want to believe. So stories make for really potent science communication. You'll hear more about that tomorrow, or later today, sorry, from Ed Young, who's around here somewhere. The problem is that we find stories convincing even when the evidence isn't there. A large part of your job, if you're a press information officer or if you're a science writer, is to tell a compelling story, to make it interesting to read, to take the boring details of the science and convey them in a way that conveys the core finding in an interesting and compelling way. Scientists often aren't that great at that. Science writers have to be. You're writing a story. The problem is when you like the story, we tend to miss the flaws in it, much more than when we don't like the story. So who's to blame in a case like this air rage study? I would argue nobody and everybody. Right? Authors didn't show that their result was robust to lots of different possible third variables, lots of different possible things to control for. In an ideal world, they would have run the same analysis in lots of different ways and reported that it's really not robust when you do it this way, it works when you do it this way. So here's what we've got. We're describing it fully. We're describing the limitations of it. Authors could do a much better job of describing the limits of their work. The reviewers, they missed the flaws in the statistics. So whoever was asked to review this probably was sympathetic to the storyline and the theory, but probably didn't think carefully about the evidence or didn't have access to it. The editor, maybe for not selecting statistically savvy reviewers, but that's really hard to do because there's a limited number of statistically savvy reviewers who are interested in reviewing papers outside their own areas. Right? The press officers for promoting this study without critically evaluating whether it actually supported the claims that the authors wanted to make. Journalists for then running with the press releases. Any of you who've written press releases know that they often get picked up by newspapers, often stealing the byline and reprinting them. So once it's out there, it gets blown up a lot. And really all of the above, because we all are human and we all focus on the information that's in front of us rather than thinking about what might be missing from that information. So science inference is about control, about ruling out confounds and alternative explanations, and it fails because scientists are human and we like stories. There are a lot of other cases of this, and I think one of the reasons this particular example is nice is because it wasn't an experiment. Right? It was descriptive data with a really large data set, a complex data set, and you have to figure out how best to describe what's available in that data set. And there are lots of other cases like this. So here's a common example. This claim that violent shows inspire violence, study says. So there are, in other words, that's basically, you watch that and you get something like this. This is a really common complaint, mostly from old farts, about newfangled technology. You can trace this back to rock lyrics, people claiming that rock lyrics caused violence, or that rock lyrics played backwards caused suicide, violent video games, too much screen time. You can trace this sort of moral panic about new technology back to at least the printing press, when people were concerned it would undermine memory, right? Moral panics are appealing because it allows old farts to blame their problems on the newfangled stuff the young ones are doing, right? The kinds of music they're listening to. There's remarkably little evidence supporting any of these moral panics. And it's kind of remarkable because you'd never see that if you read most of the major news media. Right? Most stories about the negative effects of video are about the negative effects of video games. Most stories are about the negative effects of different kinds of music. Right? Most are about the negative effects of violence television. There are many studies out there that question these original findings, or that challenge them on statistical grounds, or actually show that there's not much of an effect there to begin with. And those don't get nearly the media coverage of the more sensational story that people want to hear, or at least a subset of people want to hear. The proponents in general, because they tend to be old farts, are prominent, and the incentives are aligned to focus the field with the storytelling studies rather than the critical ones. I want to give you one example. Sometimes these can be quite dangerous. So this is Susan Greenfield, Baroness in the UK. She regularly makes this mistake in very visible ways. Here's a quote from Susan Greenfield. When people say there is no evidence, you can turn that back and say, what kind of evidence would you imagine there would be? Are we going to have to wait 20 years and see that people are different from previous generations? Sometimes you can't go into a lab and get the evidence overnight. I think there are enough pointers that we should be talking about this rather than stressing not being able to replicate things in a lab instantly. There's an element of truth to this. Doing a laboratory study of violence and aggression might not generalize to real-world problems. There might be changes over time between people and generations as a function of what they're doing. There's constant fear that young kids are spending too much time on their phones, and that's going to have lasting consequences for them. Same sort of idea. But here's where she takes this. I point to the increase in autism, and I point to internet use. That's all, right? She's actually making the argument that overuse of the internet is causing the increases in autism rates. Right? There's obviously not an experiment on that. And you've heard the adage, I assume everybody here has heard the adage, correlation doesn't equal causation, right? But people, and even scientists, ignore that when the story is compelling enough. Here's my favorite example of correlation causation. The global warming is caused by the declining pirates. I'm not sure this trend has continued, though, because we had an increase in Rwandan pirates for a while. So here's a quick trick you can use to spot an unsupported causal claim, like, for example, the first-class air rage study. You can spot cases in which a causal claim really wasn't justified. One thing to look for is, could this have been an experiment? Could it have been an experiment? Experiments aren't the savior of all of sciences. A lot of science that's critical is descriptive and observational in nature, or it involves complex analysis of very large data sets. There's nothing wrong with that. That's actually a fundamental part of discovery. But you have to be very careful when making causal claims in the absence of an experiment. And there's some good reasons why. If this couldn't have been an experiment and the story is a causal claim, you need to be very careful to make sure that there is a ton of evidence. You need a ton of converging evidence about that causal mechanism from different approaches and different subfields. So take, for example, the case of global warming. Right? If you want to make an argument that for a causal mechanism for global warming, right, we can't do an experiment because we only have one globe, but you can get converging evidence from many different disciplines, from geology, chemistry, physics, meteorology, hydrology, oceanography. Many different subfields of the sciences can provide converging evidence about mechanism. Same is true for cigarettes causing cancer. You can't do an experiment in which you randomly assign people to smoke cigarettes or not. Right? But you can look at converging evidence from chemistry and biology and psychology and many other disciplines to show that these two things, the causal story that you have from observational data, is compelling. Without that sort of multiply determined mechanism, causal claims should be tentative. Right? They shouldn't be strong claims that walking through first class causes aggression. Without an experiment, it's really hard to come up with that strong a claim from a single study. And that's true for almost all social science claims, the area that I tend to work in the most. If a study wasn't an experiment, you should be skeptical of causal and mechanistic claims. So what's so great about experiments in this context for inferring causal relationships? Well, one is that they eliminate systematic biases from uncontrolled factors. So imagine you have this hypothesis that saying you like puppies will get you more dates on an online dating site. So here we have Thor8600, who very prominently says one of his favorite things is that he loves puppies. Right? So let's say you have that hypothesis and you design a study and you get people and you look at whether or not they list puppies, right, and whether or not they get dates. So you can have loves puppies, right? He loves puppies too, and he loves puppies, and he loves puppies. And then, no puppies. Right. So if this is your study design, you might find that the people who love puppies get more dates, right? It's interesting that the emperor gets quite a few dates, but he does have the force. So what's the problem here? This one should be pretty obvious, right? There's an obvious confound in your study design. This isn't a good experiment because you've got all the pretty people on one side and all the evil people on the other side. If you are just assigning people to groups after the fact, or you look in an observational study to say who lists puppies and who doesn't, and you find this pattern, you don't know whether you have to control for evil, right? There might be many other factors, evil, ugliness, the fact that somebody's a cartoon. There are lots of things you have to control for. In fact, there are an infinite number of things that you potentially have to control for. And that's the danger with an observational study, is that you can always come up with an uncontrolled variable that you hadn't thought about that might contribute to the result. So biases like these might be intentional, or they might be accidental. Here it's intentional, obviously, but it's kind of like observing planes that happen to have a first-class section or don't. There are things you can do to statistically control for that, or try and equate those factors. But anytime you're dealing with an observational study, there will be differences that aren't controlled systematically. So if so, those biases, whatever they are, even if you could replicate it, maybe you could get another airline's data and show exactly the same pattern, but you might be replicating exactly the same confound. So the solution in this context is a randomized controlled trial. And this is a nice illustration of it, I think. You can imagine that we'll call it gum. You've got an infinite pool of gum that you're sampling from, right? And each piece of gum has different flavors. Or imagine these are people. Each person has different personality traits or characteristics. They're pretty or ugly. They're evil or good. Things that you don't particularly care about for your study, but you don't want them to systematically bias your outcome. You don't want all of the pretty people in the likes puppies condition, right? So you could, instead of doing it the way that I described before, randomly assign people profiles and add likes puppies or not to them. If you randomly assign people, and imagine the green balls are the evil ones, right? In principle, you're equally likely to have the same number of green balls on each side because you're randomly assigning them to conditions. In any given study, you might not. But over time, and with replication, if you did this over and over again, the green balls would be equally likely to appear here and here. So would the yellow balls, so would the purple balls, so would the red balls. Any other difference between the two groups that's arbitrary, that's not controlled for, is equally likely to end up on either side. So in an experiment, if you could replicate it over and over again, you've eliminated those confounds. You've eliminated the systematic differences that you don't care about, so that you can really focus on the thing you do care about, the primary difference between the conditions. That's the goal of experimental control. It's to equate everything but the two things that the thing that you're trying to tease apart. Now, an advantage of this approach is that you really can not worry as much about all of those additional variables, provided that you have replications and provided that you have a large enough study. So imagine you wanted to do a study testing whether uniform colors in sports teams affect whether or not they win, right? Or whether they get called for more fouls, whatever kind of hypothesis you might have. Maybe you think people who wear black uniforms are more likely to get called for fouls. You randomly assign players to 2 teams of 5. One might happen to have more good players than the other. You might end up with a team that has more tall players than the other in any one experiment. You've assigned 5 to each group. It's random. But if you were to do it over and over and over again, the tall people would be equally likely to end up on the team with black uniforms and the team with blue uniforms. So over time, the only thing that would be left differing between those 2 groups would be the color of the uniform. That's the idea of the experiment. So even if you control for lots of factors in an observational study, you can't ever think of every possible factor that might differ between the 2 groups. And random assignment gets rid of those systematic biases that you didn't control for. So getting back to this question, could this have been an experiment? You can rephrase this. Could this participants, if it was a social psychology study, could the participants have been randomly assigned to the treatment and the control group? If not, then it's possible to come up with other explanations and confounds in every case. So let's try it out with some news stories. This is a common problem. I know for any of you who have written journal articles and then had them covered in the media, any of you who've written articles for media outlets as a science writer, you know that the writers almost never have any control over what the headline is for a paper. So the journalists aren't necessarily to blame here. The press officers aren't necessarily to blame here. Could just be the headline writers. But often you can help the headline writers get it right. So here's one. Eating fatty fish lowers the risk of dementia. So could this have been an experiment? Well, maybe you could assign some people to eat fatty fish and other people to eat fried fish and then measure dementia as an outcome. But you probably couldn't do this as an experiment with a long enough time window to actually have this be meaningful. Right? So more likely than not, this was not an experiment. It was an observational study, and it probably compared people in 2 different populations. Might have compared, for example, people in Japan who eat a lot more fish than people in the United States, or maybe the people in the United States eat more fried fish. If you're comparing 2 different groups of people, there are a large number of things that might contribute to that difference that have nothing to do with fish, right, and what fish they eat. Okay. So odds are good that this was a comparison of 2 different groups. How about this one? This one actually pops up repeatedly over the years, and I'm not sure who exactly likes this story. But this is shown up every 5 or 6 years as a story in the media from another study. And it might be the same group driving it. I don't really know. I haven't looked into it. But so could this have been an experiment? No. Why not? Would you participate in a study in which you were randomly assigned to do housework? Right? It's almost certainly not possible that you randomly assigned a large enough population of people to do housework or not do housework, and then subsequently measured the breast cancer risk rates. Right? It wasn't an experiment. There could be lots of differences between the people who do more housework in these studies and the people who don't, right? That have nothing whatsoever to do with the proposed causal mechanism here, which has something to do with exercise from doing housework. Okay, here's another one. Neighborhoods with more green space may mean less heart disease. This one's more subtle, right? May mean is a kind of causal claim. The implication is pretty strongly causal. The arguments that have been made in this literature are almost exclusively causal, in that people then promote increasing green space as a way of then cutting heart disease. You can try to control for confounding variables, differences in the kinds of neighborhoods that have green space and don't, differences in the populations of people who live near green space and who don't, differences between urban and rural areas that might contribute to these same factors. There are lots of things you can try and control for, but there are confounders that researchers are never going to suspect because it's not an experiment. You don't necessarily know what things might lead to a misleading conclusion, and you can't control for everything. The key is, do controlling for different things lead to different results? Here's another one. Sexual lyrics prompt teens to have sex. Okay. Could this be an ethically conducted experiment? Maybe you could assign kids to listen to more sexual lyrics and then see if they have more sex, which would be kind of I don't know whether that would have to be reported as an adverse outcome in some context or not. I bet you can think of a different causal interpretation to this one. Anybody have an idea of an alternative causal explanation? There are an infinite number of them, but what would be one alternative to listening to sexual lyrics causes kids to have sex? Yeah. Yep, the cause might go exactly the opposite direction. Kids who are having sex tend to listen to more explicit lyrics. It could be that the same kinds of kids who have sex also listen to sexual lyrics, and it has nothing to do with the causal relationship between these two factors at all. It might be a third factor. Right? It might be kids who matured younger tend to listen to more sexual lyrics and tend to have sex more often. It could be lots of things. From an observational study, you can't determine which cause is right. Here's my favorite of these. Sex keeps you young. Right? Couples who have sex at least 3 times a week look more than 10 years younger than the average adult. Anybody come up with an alternative cause? Okay. Let's take one that actually plays out a lot in the university setting, and it's playing out here among many other places. This is one of maybe 3 or 4 papers just in the last 2 or 3 years claiming that the GRE is not useful. The GRE standardized test is not useful in predicting outcomes in graduate school. It's not useful in predicting numbers of publications or success in getting a job, the factors that people value in academia, not successful in predicting H factor down the line. So there are a number of these studies. They're all useful observational studies. They're not randomly assigning people to take the GREs or not. Right? What are they doing here? Well, they are looking at people who were admitted to graduate school and then are looking at their GREs and seeing whether the GREs are predictive. In this case, it was Vanderbilt Medical School. Take a hazard a guess what the average GRE score, the median GRE score of people who get into Vanderbilt's biomedical sciences program is. It's well over 1,400. So the first thing you've done is massively restricted the range of GRE scores. But more importantly, what you've done is you've conditioned on acceptance to these programs, a factor that's driven by GRE scores. So they got into the program partly because of their GRE scores, and that leads to a bias in how you interpret the results. It's like a restriction of range problem. You've limited your population to those who were accepted. When you limit your population to those who are accepted, it's dangerous to make any causal claims about the relationship between GREs and subsequent success, because they're interrelated. So you're conditioning on successful admission here. So this is an obvious confound to look for in this sort of study. People want to make this claim. People want to make the claim that standardized tests are lousy. Right? They don't like standardized tests. People don't like standardized tests generally. It makes for a good story. There's not a whole lot of evidence to support the claim that GREs are bad predictors. In fact, standardized tests are among the best predictors we have of most things. So they're not going to predict everything. They're not perfect. There's lots of variability, but they're actually pretty good predictors. So if you wanted to do this as an experiment, it'd be very hard. If you wanted to do it as an observational study, you'd need a really large data set of people who took the GREs, base your admissions decisions explicitly blind to the GREs, and then look to see whether there was a difference in outcomes as a function of the GREs, controlling for the other factors that might be correlated with GREs, like things like GPA or performance on other sorts of measures. It's not a simple problem. Unfortunately, it's often framed as a simple problem of prediction. Okay, so coming back to this, experiments allow causal inferences because they're unbiased in the long run. And unconsidered confounds, things that you haven't thought about, are equally likely to end up in each group. But an individual study is not necessarily unbiased. A single experiment might end up with all the tall players on the same team, just by random chance. And if that's the case, you shouldn't be drawing really strong causal claims from a single small study, period. It doesn't really matter what the study is of. If it's a single small study, you really shouldn't be drawing strong claims of discovery. You need replication. One of the reasons you need replication is you need to make sure that there wasn't any sort of arbitrary bias in that particular sample. Inferences from experiments depend on having appropriate subject populations, appropriate sample sizes, and appropriate control groups. And when evaluating an experiment, you should ask yourself, what are the constraints on the generality of the study? What can it tell us? Many experiments don't really allow broad conclusions, and some provide only noise. So there are a number of common shortcomings of experiments, and I just want to kind of quickly highlight a few of these. Perhaps the critical one that often is something that people can be aware of pretty easily is, was this a small study? Right? If it's a study of 20 people's GRE scores, you probably don't want to put much stock in it. Right? If it was a small experiment with 10 or 15 people per group, probably don't want to put a whole lot of stock into it. And you'll hear some more examples tomorrow of when you should put stock in that sort of a study or not. But quite often, representative samples is a critical issue, and it doesn't get discussed enough. A small sample could be okay under the right conditions, but a non-representative sample can be a real problem. There's a new Twitter feed called Just Says in Mice. I strongly recommend you follow it. As the Twitter handle suggests, the only thing it ever tweets is the words "in mice" in all caps, nothing else. And it retweets story headlines from the media where "in mice" wasn't mentioned. Exercise during pregnancy protects children from obesity. In mice. Mice children. Now, that might be a critically important study, but it really should be exercise by mice during pregnancy, right? You don't want to generalize to people from mice immediately. There are a lot of steps between those stages. Now, you might want to have a mouse model that's actually a good model in some contexts for how people perform, but you don't necessarily want to make that leap immediately from the single mouse study. This is a common problem. Many of the honor students who I've worked with here who write their theses dealing with mice talk about things like adolescence and never mention that it's adolescent mice. It's a regular problem. It's also a problem in other contexts that are less obvious. So if you look at the brain training literature, cognitive training games, many of the claims in the brain training literature are about healthy aging or healthy college students or normal, typical adults. Many of the studies that are touted as the best support for those claims are from people with schizophrenia in a clinical setting. Not clear that that generalizes. It's not clear that it's the same population. It's not clear that that inference is valid. It might be or it might not be, but there are a lot more steps necessary to make that connection. Another major problem in a lot of these sorts of studies is the use of inadequate control groups. So a control group should have everything the same except for the thing that you think is critical. Uniform color in that simple example I was giving. Or if you're doing a brain training study, you want to make sure that the only thing that differs between the treatment group and the control group is the critical ingredient of the brain training intervention. One of the problems with brain training is nobody knows anything about what the critical ingredient could be because there's no good theory about it. But you can see for yourself, if you're reading one of these studies, whether that control group was appropriate. So imagine you did 50 hours of training on a really intensive computer-based attention task that gets harder and harder the more you do it, right? And your control group is surfing the internet or watching educational DVDs. Are those matched in all of the things except for the critical training ingredient that you think is important? Almost certainly not. Right? But that's a common control for a lot of these studies. If you have an inadequate control group, it's really difficult to determine what you can conclude. You have to match the treatment and the control groups in order to say that it's the element of the treatment that mattered. Right? Imagine you did a medical intervention where some people get the intervention, which is a new drug, plus lots of individual attention from the experimenters and lots of therapy, and then the control group just sits at home waitlist control group or a no contact control group. Do you have any idea what helped if the treatment group does better? Might have been the drug, might have been all the social interaction, might have been having something to do during the day, could be anything. And without the right control groups, you don't know. Another issue is opaque publishing practices. And this is something that you as a press officer can ask about and should ask about. Scattershot publishing is quite common, where people will take a large study and publish pieces of it in lots of places. Are there hidden data? Are the data publicly available is something you can ask to see, have all of the analyses been presented? Are there multiple publications? You can ask a scientist, hey, have you published on this study before? Are there other papers you've published based on this study? That's a good question to ask, because if they have, and they haven't made it clear that they have, that's a real problem for how you can draw inferences from it. You should ask if the outcomes from the study have been published before. You might find cases in which they have, and people don't realize that that's not always a good thing. Selective reporting of outcomes is a big problem. So does the study, here's a good clue for you to look for a problem in a study. If you're doing a large-scale intervention, right, and people are, say, doing 50 hours of training in one group, and then they're doing different kind of training in a different group, and you've got hundreds of people doing this, that's a very expensive long-term study to do. If the paper reports one outcome measure, is that plausible? Imagine running that study yourself. Would you run a study for hundreds of thousands of dollars with 100 people doing tons of training where you're in the lab all the time and only measure one outcome? No, of course not. It would be completely cost inefficient. No funding agency would go for that. Right? You're going to run a battery of tests. So if a paper is reporting only one outcome, you should be asking, what are all the other outcomes you measured? Or were there any other outcomes you measured? Or were there any other things you studied here? And if there were, those need to be reported, because otherwise you're only reporting the analysis that happened to work in the way that you wanted it to. A last issue that's quite similar to what happens in observational studies is attrition and exclusions. And this is something that's quite subtle, but it's a really critical problem in the interpretation of randomized controlled trials. If you have dropout from your study, you no longer have random assignment, because the people who dropped out might differ fundamentally from the people who didn't. And that difference might contribute to differences between the groups. It's even worse if you have a study where people self-select into follow-ups. So one of the largest studies, intervention studies, in the cognitive training literature was the ACTIVE study. It was about 15 years ago. If you ever hear a news report saying the largest ever study of older adults in cognitive training finds X, it's almost certainly that study that was done 15 years ago. It's not a new study. And there are reports like that every year about the ACTIVE trial. Great study in a lot of ways. One of the things that the ACTIVE trial did was they gave 10 hours of training in 3 different kinds of conditions, and then a year or two later, they gave people the option of coming back in for a booster training. And a small subset of the people did. Any analysis based on that booster training is uninterpretable, because people self-selected to come in and do that booster training. The people who chose to be in that study might be fundamentally different from the people who didn't, and people might differ based on which training condition they had on whether they chose to be in that study. So it's like people deciding, hey, I'm pretty, I'm going to say I like puppies, right? It's a fundamental problem that introduces a confound. It eliminates the random assignment that your study had bought you. Okay, so some just broad conclusions here. Observational studies are descriptive, right? And that's a fundamental aspect of science. Large-scale data where you look at the relationships among variables that might be important are really important to science. They're hard to do well because you have to think about the confounds in the associations you're looking at. It helps if you're dealing with a very large sample. It helps if your sample is representative of your population, so you can draw conclusions at a broader level. If you want to make a causal claim from a study that wasn't an experiment, eating fatty fish reduces dementia risk, you have to have converging evidence, extensive converging evidence of the mechanism. A single association doesn't give you the mechanism. You have to do more than that. And it should be robust to a wide range of analysis choices. If the effect flips if you control for a different variable, you've got a problem. It might still be right, We don't necessarily know which outcome is right, but you should have a sense of whether this is robust to a lot of different kinds of analyses. Now, experiments allow causal claims more naturally, but they also have to have appropriate control comparisons. They may be limited in scope and generality, and bias control, actually having that bias control benefit requires replication and ideally large samples. With sample sizes of 5, you're not going to get there. With sample sizes of 10,000 basketball players, you might. So what you need to do as science writers, there's a lot of great science to communicate out there. And as scientists and science writers, the key is to make sure you explain what the result means and how it's limited. And that's something that scientists have not done a good job of and could really help press officers and science journalists if they would say, here are the constraints on what we can say. As scientists, we shouldn't be making grand claims without grand evidence. And as science writers, you can focus on what the result does and doesn't show. And I like to think of this as focusing on the constraints on generality. It might be a really great study on mice and obesity. Say that and say, we hope to study how this translates to humans, but we don't have evidence for that yet. So that the stories about it don't focus on the evidence about humans. If it's in mice, that should be in the first sentence and in the headline, not buried someplace deep in the article. If your sample isn't representative, that's okay. If you're doing a study of brain training in people with schizophrenia, that's fine. Make that clear. Make clear that it's not known whether it generalizes beyond that group. If you're controlling for a ton of possible confounds in an observational study, you should note if it's robust to other choices. If not, the claims should be limited. The result might still be interesting, even if it's not the one study to rule them all, right? And the most important thing is, don't claim a discovery from a first experiment. First experiments often turn out not to hold up. So if it's a first experiment in something, and this is a common line that I see in press releases, this is the first ever study to demonstrate X. That's great. It's great that it's the first study. It should be tentative, because as the first study, it might be later proven wrong. So if you make that sort of strong claim of a discovery, discoveries need backup. Discoveries take time. They take finesse, and they need checking. Without that, we get chocolate is good for you today, and chocolate is bad for you tomorrow, right? So broad principle is be careful, especially when a story matches what you want to believe. Those are the cases where you're most likely to fall prey to promoting something that's maybe noise rather than signal. Okay, I'll stop there. How are we doing on timing? Do you want?
We have 5 minutes.
Okay. So do 5 minutes for questions.
Anybody wants to ask? We do have microphones that we want to bring to you.
I can repeat the question too.
Oh, you want to-
Yeah, I can just repeat it. That's fine.
So for us who are science writers and researchers working together then to
Mhm.
address these kinds of issues, do you have any good examples that you can point us to, or do you have any, maybe even literally the exact phrasing of the question from the writer to the researcher, or
Mhm.
vice versa, so that we can better address some of these generality issues?
Sure, yeah. I don't have a written list I can hand you, but there are a lot of things you can ask. So if it's a new experiment, so the question was, are there things that I could recommend for a science writer to ask to a researcher to make sure that they're addressing these limits on generality? Yeah, so there are a number of things you can ask. So the first is, did you run additional analyses? Were there other analyses that you ran, and did they all show the same pattern? Right? Are there other variables that you didn't look at, or you might have not controlled for? If it's an experiment, are there any other differences between the baseline condition and your treatment group that might contribute to the result? You can ask, how broadly does this, so a nice way to ask this is, how broadly do you think this generalizes? So you tested undergraduates in a lab. Do you think that generalizes to adults? Right? Will it generalize to my readers? Right? And if so, do you have evidence for that? Right? If they don't have evidence for that, you can say they speculate as opposed to they show. Right? And that's a big difference. Another thing I think some writers will do very well is if somebody were skeptical of your result, what would they say? which is a nice way of getting them to address the constraints themselves. Are there people who would disagree with what you're arguing here, and what would they argue? Right? Most scientists are used to arguing and arguing with other people, so they probably have a pretty good feel for what critics will say about their work. And if they've done a good job, they've anticipated those criticisms and addressed them. You can always ask, who would be some people I could talk to who might be critical of this result? See if they give you anybody. They probably won't. But yeah, I think there are a lot of things you can ask. So is this sample, who are you generalizing this to? Who's your target population? So are you studying one species and trying to generalize to all species? Are you studying one kind of people and trying to generalize to all kinds of people? Whenever people are doing that, and often their articles will say, people do this, right, without any constraint on it. And what they really mean is college sophomores at a Midwestern university do this, right? And I think it's a great question to ask, are the people in your study, are you generalizing from this population to a broader population? If so, what population, and how much evidence do you have for that? That captures a lot for experiments. If you ask that question about generalization and what evidence they have for it, if they don't have evidence for it, as a writer, you should be skeptical of making really strong claims from it. It still may be a really cool study. And there are lots of cool studies that are done on college sophomores that have interesting results that might be general, but we don't know yet. That's great. That tells us where to go next. Right? So I think if you can nail down what they recognize as the limits of it are. If people have done a study, if you've done a large observational study, studies in economics, studies in personality research, do this sort of work where you've got large-scale studies with lots of factors to measure and control for. Right? You can ask, so you controlled for all of these factors, are the results robust without them, without those controls? What about with other variables if you control for them? Why did you choose these, and are there other reasons you might choose others? So it's hard because if you're not trained as a scientist in that area, it's hard to come up with the right questions to ask for that study. But questions about generality, about the sample that they're studying, about what they're generalizing to, are kind of universal. And those should apply to just about any study that you're writing about.
Okay, I'm sorry, that's all we have
Okay.
time for. Dan Simons and May Berenbaum will be leading a final workshop at the end of these 2 days, so I hope you come to that as well, and there'll be opportunity for more back and forth. So, thank you so much.
Diana, is it a break now? Is it a break now? Do you want to announce that? So I think we have a few minutes break now. What time do we start up again? 10:05. 10:05, okay.
What's that top one? Is that, you know if that's the newest one that they
Yeah, it's the one she just sent me.
just sent? Perfect. I'll go ahead and spread them out.
Here's your clicker. So you got the pointer, and then this just, if you hit this one, it blanks it out, so just hit it again and
Okay.
it'll
Yeah,
come
that's
back up. But just the arrows and the pointer.
Thank you. It's sort of just right here. I think if you do that. He likes it. Apparently likes it directly there, so that's right. No. If I have to. That's fine. It'll be fine.
It should be okay. Should be all right.
He likes it better when it. That's fine. But is it in the? That's where the transceiver is. It's set
Yes, yeah.
Welcome back to Amplify the Signal. I have to tell you, nobody who has published anything wants to be mentioned by this next speaker. At least not in his website called Retraction Watch. Ivan Oransky is the co-founder of Retraction Watch. It's a site that reports on mistakes, fraud, and scientific integrity. Well, you'd like to be mentioned for your integrity, right? Ivan is both an MD and a science journalist. He's distinguished writer in residence at New York University's Carter Journalism Institute, and he teaches medical reporting there. He is vice president for editorial at Medscape and is the president of the Association of Healthcare Journalists. He brings the perspective of an editor as well as a reporter. Today he's going to help us discover how journalism can reflect what's really going on in science. Please welcome Dr. Ivan Oransky.
Thank you. I do get that a lot, actually. Actually, someone just the other day, we highlight all sorts of things at Retraction Watch. One of the things we like to try and do is promote other stories, the stories that we haven't written that are about scientific integrity or sometimes scientific fraud. Unfortunately, I guess probably once a month or so, someone says, you really gave me a jolt when you linked to me and all of a sudden I saw traffic from Retraction Watch or you tagged us on Twitter. I hope that it's clear that we're trying to actually promote things that we think people should read. It's not that we think it should all be retracted. In fact, I actually don't think retraction is the best way to handle problems in the scientific literature a lot of the time, but maybe we'll get to that later. Thanks very much to Diana for putting this together and for the really kind invitation and for making it possible for all of us to get together today. I have worked with, or I know of, and have deeply respected so many people here in Urbana-Champaign. I haven't actually been here, so it's a pleasure to be here. What I'm going to try and do in the next little while is, if you will, synthesize a number of different ideas and different themes that sort of go on in my head. So if it appears that sometimes I'm contradicting myself, which I do, sometimes the ideas aren't quite, just together. I don't want to apologize for that because I think the point here is to get us all to think in different ways. So hopefully I'll be doing that. But the punchline of that is, please, it's not an interruption if you have a question or want to ask me something or ask me to amplify something or, frankly, so to speak, amplify something, right? Or, frankly, challenge me on something. I'd like that. I do speak to groups like this. I speak to, and I teach larger classes too, but most of what I do is teach a seminar, in fact, or small classes, I should say. In fact, one of my former students is here. I don't see her right now, but there she is. Yep. Hello, Crystal. And so I hope she well knows that I very much welcome the conversation. So please treat it like that. I have some slides and some quote-unquote data that I'd like to share with you, but really I want this to be a conversation about, again, how journalism can reflect what's really going on in science, which we all know. We all know what's actually happening in science, but often it's not apparent either in the journalism that we read or, frankly, in some of what we do as writers and editors and video producers and podcasters. So without any further ado, just a little bit of further ado, apparently. There we go. Okay. So a lot of you may know this cartoon. It's a bit dated now in a few different ways. One of which is the guy, sort of white guy, doing the news, which thankfully is changing, not as much as it needs to be, but changing. But the other is, how many of you actually, sat down and watched the evening news last night and got your science or medical news from that? Yeah, a lot of you. You just can't see, but no one. But this still holds to a large extent. In fact, it's, I think, very consistent with what you heard from our previous speaker, from Professor Simon, that, in fact, what we're dealing with, of course, is a lot of these observational studies. So I know a lot of us, including myself, drinking coffee this morning. I had one out there, delicious coffee with all the tasting notes. It was wonderful. Coffee can cause depression in twins. So those of you who are drinking coffee in twins, I'm sorry, I guess. But obviously, what this is lampooning, I think, quite effectively, which is why this cartoon, even though I think it's at least 20 years old now, really holds up. This cartoon from Jim Borgman, who won a Pulitzer at one point for, not for this, but for some other work in politics, is that we are dealing too much, we are seeing too much with the single study problem. And these are observational studies, of course, and I won't go back over what you heard in much more eloquent and elegant ways from our previous speaker, but that's what we're dealing with. But it is, unfortunately, and in my world, as was mentioned, I trained as a doctor, so I tend to focus on healthcare journalism and on medical journalism. This is the rule rather than the exception. And to give you another example, some of you may know about this site too, and I don't know if you can quite read that, I apologize, in the back. But this is a site called Killer Cure. There's the URL. And it says, help to make sense of the Daily Mail's ongoing effort to classify every inanimate object into those that cause cancer and those that prevent it. Now, this is only this actually goes on for pages and pages. It's alphabetical. It is, as our friends in the UK would say, from A to Z. Ben Goldacre and his group did this a number of years ago now. It actually isn't updated anymore, which is unfortunate, but I get it. I have lots of projects that you do for a while, and then you kind of have to move on to something else that's really inspiring you. But it's really pretty smart. And of course, many of you may know that the Daily Mail is often referred to as the Daily Fail, particularly when it comes to science and medical coverage. This is really a good example of that, because as we all know, every inanimate object either causes or prevents cancer. Isn't that true? Haven't we proven that many, many times? It gets really complicated. It's not on this slide, but when you go to alcohol on here, for example, because it somehow manages to do both. How on earth is that possible? Obviously, it's not that it does neither. It just sort of is so complicated. And yet, everything is reduced to a single study, right? So a single study sort of vaguely, if you squint and look, and flip it upside down, says what the Daily Mail says it does. But this is, again, sort of good examples of this sort of single study problem, which I want to get back to. But again, these are almost all observational studies. Not all of them, actually, but most of them are observational studies. There was no experiment, as we heard from the last speaker, would be the sort of, the really best practices, the gold standard. And by the way, just to sort of, I know it's fun to look at this. It's fun to look at the previous cartoon. The Daily Mail actually, at least as of a couple of years ago, the data that I saw, we can sort of all laugh and say, oh, well, who sort of reads that and looks at it? It's actually the best read. It has the largest audience of any online news outlet in the world, right? We all like to, you can pick your poison or, pick your prize-winning newspaper outlet or television station, NPR, what have you, and say, oh, that's what everybody listens to because I listen to it. I can assure you that's not the case. I very much doubt, although I have only met a handful of you, that those of you in this room are representative of reading and media consumption patterns in the world. I'm actually completely sure of that, despite having not done an experiment. So there you go. Which, by the way, brings me to another sort of disclaimer that I should make, which is that I am a journalist. Yes, I went to medical school, and those of you who are proper scientists will sort of say, yeah, that doesn't count either. Totally, I'm with you on that. I worked in labs for a couple summers. There are papers, if you sort of dig far enough into PubMed, you will see papers with me as like fourth out of eighth author or whatever it is. And please don't ask me what those papers actually, no, I do know what those papers said, but I'm not a scientist. I don't traffic in data. I traffic in anecdote, which, as we know, is a terrible, terrible habit to be in. But I want to sort of state my disclaimer very clearly. I do actually have some data. I also like to, as my students well know, I think, I like to set very low expectations because then I always meet them. So if I tell you I don't know anything about data and then actually show you some, well, you'll be like, wow, that's, I will have, there's probably some non-reproducible priming study that I've just, somehow reproduced. Anyway, sorry, that was an inside joke. This is literally hot off the presses, presses in the electronic sense. I actually got an alert about this when I got off my flight last night. This is from JAMA, just appeared yesterday. Why bolstering trust in journalism could help strengthen trust in medicine. So again, I didn't write it. I was glad it appeared. I don't really know. I mean, I sort of have followed the first two authors, but Gary Schwitzer is a former colleague on the board of directors of the Association of Healthcare Journalists. Gary, it still exists, although unfortunately it no longer has funding, so it's not updated very often at all, but Health News Review, which I will get back to in different ways. But, and so the idea here, again, I mean, it's all sort of in the headline. The headline, they did, I'm pretty sure, write that headline or at least have control over it. I will just slightly differ, not so much differ, but with what our previous speaker said about headlines. It is sort of globally true, or sort of at a high level true, that you don't have complete control, or you don't have control over your headlines as a journalist. On the other hand, and I always tell my students this, I don't know too many editors who, if you write a headline that actually sort of fits in the space that you if you can ask where it will fit, how long it has to be, and does the thing a headline's supposed to do, which, and we may also differ on the, I don't actually hate the, I hate the term clickbait because of what it's meant. My job is to get people to click on things. That's what I get paid for. So again, we can maybe have a conversation about that, and this is not a disagreement as much as just the way terms are used. But if you write a headline that fits all those criteria and you submit it along with your piece, there's not a 100% chance, I don't know what the percent chance is, but it's a far greater than 0% chance that it will actually end up as the headline. Again, that's up to you. And he's sitting in the back of the room, I'll embarrass him, but Ed Young has definitely, I still think it's my favorite headline. I'm pretty sure you wrote it. Maybe someone at the Atlantic helped you, but it was about shampoo, which maybe you'll talk about, but I just thought it was about correct me here, but sort of study of using something that was sort of like fecal transplant, but not like fecal transplant, so shampoo. You get it now? Okay. Yeah. It's even more clever than that, so I don't want to steal Ed's thunder. But anyway, so hot off the presses again, people are talking about this stuff, so let's keep talking about it. Let's go forward though, rather than backward. So again, and I am not the first person, hardly. I believe I wasn't even born when the first person who warned us about single study story problems. But this is something from outside. I think it was actually 2000, maybe even 5 years ago now. I should have included the date, but there's the URL, and Aaron Berasini who wrote this. I won't read this to you, but again, this is from outside, which is, as you know, environmental people who like to be outside. That makes sense. Good title. And so again, I was talking about health stories like this. This is a slightly different spin on it, but she's saying, look, we've all done this. How can we not do this quite as often? Keep doing that. There you go. And it happens everywhere. So I've sort of been talking about health and medicine and what have you. It happens in ecology. I won't read this to you. My slides, if they're not available, I hope they will be, but I'm happy to make them available. This is a paper that came out just earlier this year. Alarmists by bad design strongly popularized unsubstantiated claims undermine the credibility of conservation science. Okay, so again, even happening in ecology. This is, again, not just studies about coffee and twins and depression. And one of the issues, and so I warned you that I was going to try and combine a number of my various, streams of consciousness, if you will, thinking and sort of things I think about a lot, and issues that, varying in varying ways either amuse or anger me, often at the same time, is that one of the things we have allowed to happen, and we being certainly science journalists, but frankly, those of you working in press offices, frankly, journals themselves, frankly, lots and lots of other people, government agencies as well, is we have allowed, and part of the reason why single study stories are what they are and how as powerful and as prevalent as they are, is that we've allowed journals to tell us when and almost how, in fact, and I would argue how, some might differ on that, science actually happens. So, back in the day when there wasn't something, an alert that I got the night before and I can throw it into my slides, it was a weekly publication or a monthly publication or what have you. Science happened, according to the New England Journal of Medicine, right? Science or medical science happened, the important medical science happened at 5 p.m. on Eastern, so 4 p.m. here, sorry, 5 p.m. Eastern on Wednesdays. And I'm sure you all know that's exactly when science happens. If you go to a medical school, you go to this medical school or any medical school, that's when you should show up to really see it. You might need to get there a little early, like fireworks, you got to get a good seat, but don't bother showing up at 6 because it's all gone. And in fact, journals know this so damn well and he's one of my mentors, and this is not something I had any mentorship in with him, but George Lundberg, who was the editor-in-chief of JAMA, a competing journal to New England Journal of Medicine, was so concerned that New England Journal of Medicine was getting all of the headlines. And again, this is almost 30 years ago now, so the internet existed, but it wasn't for us sort of mere mortals. But, it was basically newspapers, print newspapers, television, et cetera. And so he was very concerned that New England Journal of Medicine was getting all the headlines at 5 p.m., because that was right before the evening news that nobody watches now, right? That he moved all of the embargoes, because they had been on Fridays, to Mondays, okay? Guess what happened to the journals? Not just headlines. Guess what happens to the journals, and someone will throw something at me for even mentioning this horrible term, but guess what happened to JAMA's impact factor? straight up. Because all these reporters were writing about stuff, which meant all the other doctors and researchers and what have you, these are clinical medical journals, they were, learning about things that they wouldn't have learned about because all of a sudden they were reading about it in the press. And there's actually a couple of really interesting studies about that. I don't want to get too lost in the weeds. I'm happy to give you the references. Vince Kiernan, though, who I say I run a blog in quotes I created a blog called Embargo Watch. That was actually 6 months earlier than Retraction Watch, which I think many more people are familiar with. And I say that, and I cringe when I say that, because unfortunately Embargo Watch has become sort of like my older child who seems perfectly independent, so I ignore him or her all the time. And I barely ever post there. We had a good run together, and I may still get back to it. I just don't have time anymore. But more important, I'm standing on the shoulders, as Newton said, although I know even this quote, I tend to digress, as my students know, and sort of wander around. But even this quote of Newton's is, in fact, misused, and I'm probably about to misuse it. But I stand on the shoulders of giants when I write about embargoes and think about embargoes. And Vince Kiernan, who's a very patient and wonderful thinker on this issue, is whose shoulders I stand on. But this was his PhD thesis when he went back to school after being a journalist for a while. He's now an administrator at a university in Washington, D.C. But he really questioned whether embargoes are good for science. This is a kind of a little bit of a dark cover. But the idea is, if we are ceding control of when science happens to journals. Now again, there are some advantages to embargoes. Even I would admit that. You have some time to report on studies. The problem is that in the time before those embargoed studies, that embargoed material comes to journalists or comes to press officers, a lot of scientists won't talk to you. And there's something called the Ingelfinger rule, which again you have to blame on the New England Journal of Medicine, but that basically says if you talk to journalists or really anyone, and if the word gets out about your study before before you submit it for peer review, we have the right, and often will exercise this right, to not publish it. And there's at least, even though it's not actually like that anymore quite as much, a lot of scientists still think it is. And since the only way to get promoted and get tenure and the rest of it, get grants, is to publish or perish, of course, then you are left with basically only being able to report on science and on scientific findings when journals tell you can, when they send out the embargoed material. Now, again, that's a 2.5-minute version of a book, practically, so please go read the book. I wrote a piece that's maybe a précis of the book and of some of my other thoughts on this in Vox a couple of years ago. That's kind of when I basically stopped doing Embargo Watch, just because I felt like I'd said my piece, and people can agree or disagree, but there was a piece in Vox a couple of years ago now that sort of talks about this. So again, the single study problem, right, single study syndrome, as Erin Barasini put it, it isn't all just, we're all about clickbait and we all have to, want to get people to click on things that may be overstated or even wrong, okay? There's some reason, rationale to it that we need to look deeper. It's always, of course, as I'm sure you all know, and you heard again from our first speaker, are there alternative explanations for what you're seeing? Are there deeper systematic issues that we should be looking at? And I would argue that embargoes are one of them. So I'm going to switch gears a little bit and talk to you about, again, I'm trying to get across a little bit, can we report on science as it really is, as opposed to how journals want us to think it is, as opposed to how people want it to be glossy and maybe sort of not talk about some of the issues in it. I wouldn't say made a career, but I have sort of spent a lot of time thinking about how science really works. I actually taught a seminar, a first-year seminar at NYU this semester, not a journalism course, called When Science Gets It Wrong. It was really fun and interesting and fascinating for me. You'd have to ask my students whether it was fun and interesting and fascinating for them. But in going back even and reading material from the 50s and 60s and even earlier than that, you really get a sense that these are issues we've been talking about for a long time. But what happened with Retraction Watch was, so this is a famous picture. That picture isn't necessarily famous, but the story behind that picture is famous. And it's actually relatively local, although a bit dated. That's Harry Truman, President Truman, and he's holding up a newspaper that says, "Dewey defeats Truman," right? Now, as you all remember from I know most of you are scientists or you trained as scientists, so maybe you missed the history course, or the American history course, so you stopped before 1945 or 50. You remember our President Dewey? He was a very, very effective president. He invented the library. No, okay. We didn't have a President Dewey, right? Okay, we had a President Truman for a second term, actually, and there's a smiling Harry Truman holding up a newspaper. Because, and of course, this has never happened again, although it's a little bit more of an electronic version nowadays. The newspapers had to, go to press before all of the polls were closed, right? The same way that thing that I'm sure we're all staring at the New York Times was doing this until, midnight or 1 o'clock in the morning during the last presidential election. So all of these Chicago newspapers got it wrong. He's in Chicago doing this. They all got it wrong. They all had to get retracted. They were actually on the street, and people had to, the same people who threw them on the street to get people to go get them into newsstands had to go back and collect them all from all over Chicago. And so this is a sort of classic retraction, if you will. It has nothing to do with science, but it's sort of a little bit of an icon, if you will, in terms of that, what we're thinking about. So Adam Marcus, who's my co-founder and this remains very much a 50-50 effort between the two of us. Adam had been reporting on the case of a researcher named, he was reporting on this researcher named Scott Rubin. Scott Rubin was an anesthesiology researcher, pain control. He was studying a drug that many of you may have heard of. It's still on the market, although it has a big black box warning label on it from the FDA, called Celebrex, right? So the sort of cousin drug of Vioxx. These two drugs were supposed to be they would protect your GI tract, your gut, from a lot of the really awful side effects of other painkillers, ibuprofen, that whole group of drugs, NSAIDs they're called. They're called COX inhibitors, cyclooxygenase inhibitors. These were supposed to be sort of a cleaner pathway, a sort of more specific pathway that would give you all the benefits of those other COX inhibitors, but not give you the bad side effects in your GI tract. And it turns out they probably didn't even do that. I mean, they did control pain, but they had this little problem, which was that they doubled the rate of heart attacks in people. And I don't know about you, and I don't know about your family histories. I won't ask you, but doubling the rate of heart attack in my family would be a really bad idea. I mean, even having any rate of heart attack is generally a bad idea. So that's a bad side effect. And he was sort of studying that, but he was really studying the pain control and whether or not they worked very well, not so much the side effect profile. And he was publishing studies in pretty important journals in anesthesiology and pain control. They were cited in guidelines. They were cited in terms of guidance for how to use these drugs. There's only one little problem, and it's really, you can see how this would kind of be overlooked, if you will. And that was that he had made up all the patients in all of his trials. Right? And I don't know. I feel like that's fine. Really, no one got hurt. It's all good. These drugs obviously had some risks, so maybe we should thank him in retrospect. But of course, that meant that his studies were fraudulent. He had to eventually retract 25 studies, and I know that sounds like a lot, but hold that thought, because I'll show you some much more impressive numbers than that in a minute. But so he had to retract all these studies. He actually went to federal prison, which is a very rare occurrence for people who have committed scientific fraud. And what he went to prison for, technically, I'm reminded of this whenever I try and talk about this story in front of lawyers, but technically what he went, it was a little bit like, and again, I hate to keep coming back to, without saying what they are, current events, but it's sort of like, it basically is like, getting prosecuted for obstruction rather than the thing that you actually did. Okay, so that's what he actually went to prison for, but he did go to prison for something related to scientific misconduct. Now, Adam at the time was the editor of Anesthesiology News, right, which I'm sure you all read. I like to say although the publisher, who I know quite well, has somehow never seen fit to take me up on the free use of this tagline, it's the magazine for people who put other people to sleep. Somehow doesn't really ring. It doesn't work for them, Okay, their loss. But Adam, because he was a trade reporter, in other words, someone reporting on just that industry really, those group of people as researchers. He was in with he knew all of the sources in this story. He was all on top of this. And what I realized as I was watching and really, frankly, like drooling over Adam's coverage, because he was breaking so many stories on this, on such a big, important story that a certain newspaper that I guess is local to New York, felt the need to run a big story on without crediting him, and that's never happened before either. I'm sure never happened again. Adam, I said to Adam one day, and he and I knew each other through medical writing circles and what have you. I'd done some work for his publisher at one point. I said, Adam, this is like, there's clearly there's sort of something happening here. What if we started a blog about retractions? And I had Embargo Watch, so I was like, that's easy. I don't have to pay $1 million to a marketing firm to come up with a new name. How about we just call it Retraction Watch? He's like, yeah, sure, whatever. That sounds cool. And we actually thought, and he was quoted actually in the Times not too long after saying, we thought we would post a couple times a month. That was kind of how many retractions we thought there were. Our mothers would read it. That would be great. We don't have much evidence that our mother, no, we do actually. My mother does read it. At least she tells me she does, and that's enough. And we didn't really know how many retractions there were, and I'm going to get to that in a second. But there were two main reasons we launched it. And one was that, here Adam was, breaking a big story based on the fact that retractions started happening. So what we saw was, and as journalists, the thing, I don't know, any other journalists in the room can feel free to disagree here, but I love stories that are hiding in plain sight, right? We now that we've been doing this for a while and have figured out where all the sort of nooks and crannies are, we've started doing things that are a little bit more investigative. We've started filing a lot more public records requests and what have you. I may talk about that in a minute. But at the end of the day, here's a retraction notice. And it may not say very much, which is the second reason we launched it, but it is there's something there. There's something happened. And because, as I'll show you, a lot of these are due to misconduct and fraud, it's a great story, an accountability story for science journalism. And so, but the other reason that we launched it was that when we did read these retraction notices, they were sometimes useful, but most of the time somewhere between, opaque and misleading. The entire retraction notice might say the authors have withdrawn, this article has been withdrawn at the request of the authors. Now, I don't know about you. I think we're a science, pretty science-heavy crowd, if you will. I don't tend to think that there is such thing as clairvoyance. Maybe some of you, though, could figure out what happened in that retraction notice based on a lack of information. Good for you, but I can't. And so we thought there was a serious transparency problem in science also. Because here it is, these are extreme cases. This is being withdrawn from the literature. You're being told as a reader, as a researcher, as the author, that is no longer reliable. We should probably know why that happened. And so we were off. And unlike what we thought, it turned out that there were far more retractions than we ever thought there were. I'm going to fast forward quite a bit. We launched, as you saw, in August 2010, so that was not quite 9 years ago now. About 5 years ago, we started a big project with the help of three very generous foundations to do a lot of things. But one of the main parts of the project was to create a database of retractions, which you're welcome to go to. It's open access, retractiondatabase.org. You can search for anything you'd like, author, subject, journal. You can search for your university or someone else's university, depending on how you're feeling about it. And we started cataloging all retractions. And so what we thought, again, at the time, we started in 2010, there were probably a few retractions a year. What it turns out is that we were right, except we were 10 years out of date. That's a different version of right, isn't it? I think it's fine. But we were really wrong. We were wrong, and we didn't know. And so what I want to show you here, though, is this is the sort of rate of retraction that on the right. So that's a percentage. Now remember, that's percentage. That's not, but that's actually 0.004%. As of 2016, which is kind of where we know as many retractions as there probably will be based on the lag time and how long they take, it's still way under 1%. It's under 0.1%. Okay, so this is still a pretty rare event, and I think that's really important to emphasize. However, it is clearly increasing. The number of retractions, again, it's sort of did this linear thing, and then 2010, just like you don't want scientists to publish only the data that tell the very, sort of the clear story that the narrative is 100% clean. I want to be, frank with you and transparent and say that although the trend is clearly like this, we're seeing an increase in retractions. From the year 2009 to 2011, we saw a massive spike in retractions, which then came back down. So you go like this, and then like that, and kind of up like this again. What happened there was IEEE, many of you may know IEEE, and a lot of electrical engineering, computer science, et cetera. They retracted, and you can go into science, I'll get that reference for you in a second. They retracted 7,400 papers at once, or at least over that short period of time, for reasons that frankly still aren't quite clear. But it's a good reminder that, data can skew, right? So if you exclude those, we now have more than 19,000 retractions in our database. That's almost twice as many as you'll find anywhere else, which, I'm boasting, except that, of course I'm boasting, except that, that's what we look for. Don't look to us for anything else. Don't look to us for, most citations in neuroscience or whatever it is you're interested in. That's just what we do. And so the question people have for me, though, then is, well, why is this happening, right? So, and this, I hope, will be a little bit of a teaser of what I want to share with you and sort of leave you with in the next little while about why retractions are actually a good thing, and the growth in retractions is actually a good thing. There are two sort of, if you will, competing hypotheses. So they don't have to compete. They can actually get along quite just fine. But there are at least two hypotheses. There's sort of two explanations for why retractions would be on the increase. And remember that, and I'll give you a little more data on this, but most retractions, or at least more than half of retractions, are due to misconduct, okay? So that's an important sort of bit of information. One reason would be, and frankly there are people in certain camps who would like this to be true, clearly misconduct is on the rise. So clearly there is more sort of messing around and falsifying literature and plagiarizing and the rest of it. And there's actually a little bit of evidence in some fields of that. So I don't want to say that it's completely zero, but that is almost certainly the far less important explanation. And the far more important explanation is that people are actually looking, right? People are aware of these issues. They're looking for these problems. I'm going to show you just a small number of examples of the kinds of people who are looking for these issues and finding problems in the literature. And then the journals are, whether they like to or not, actually starting to do something about it. And that's pretty clear that that's what the increase is due to. So why, and again, you can almost even see that here. We launched the database sort of officially. It had been live in beta for a while, but we launched it officially in October with a big package that we worked together with Science Magazine. So you can go back and look at that. This is what that's from. It's a 6-page spread in Science. So what it appears like, and again, I think full transparency, I actually don't, I wish it had sort of stopped here. I mentioned earlier that retractions take actually on average about 3 years. Some happen very quickly. We actually posted on something this morning that took like 2 weeks. Sometimes we have the record for retraction of 80 years, which I'll tell you the story of in a second. So the point is, this is sort of misleading, and it is dotted line, and it explains why, but it looks quickly when you look at it like retraction rates are suddenly, all of a sudden dropping precipitously. In fact, they're not. What we think is that they're sort of going along, and they're now actually plateauing. We won't know that for a few years. Frankly, this could go either way. It could go down. It definitely isn't. I can see the data is continuing to sort of do this. But this is, again, as a rate of retraction, right? This is a rate of retraction per papers published. And again, it's certainly possible, this is really a speculation at this point, we may be reaching not so much peak retraction, but we may be sort of getting to our point where we're able to catch a certain number of problems and able to correct them. There are probably other problems we don't know about, but we've sort of reached capacity in that way. That's just one possibility. We really do have to continue looking at it. But I do think it's just important to know, and the other thing that's important to know also from science is, based on our data, why are papers retracted? And what this shows is that, and it's not that I dislike this, I'm red-green colorblind, so don't ask me what this actually says, but I think I can tell. At least I know what the data say, so maybe that's better. But basically, if you look at this, and again, I would stop here for now, basically, if you add together various reasons for retraction that we would consider misconduct, and that, by the way, includes a sort of clever but not very smart scheme of fake peer review that has been responsible for about 650 retractions. It's actually where people figure out a way to do their own, they peer review their own papers. And I'm sure you're all like, well, tell me more about how to do that. I'm happy to tell you more if you want me to tell you more a bit about that. But don't do it, even if I tell you about it, because at this point you'll get caught, because everybody's been writing about it. But about 60% of the time, retractions are due to misconduct. About 20% of the time, they're due to honest error. About 20% of the time, we're not quite sure. The one we posted on this morning was actually clearly an honest error. But that's important because, again, going back to what we heard in the kind introduction, people don't like to be, they don't like it when we talk about their papers. Sometimes they don't have a choice. But about 20% of the time, it's because they've retracted for honest error. We actually have a category on the site and an award we give out called Doing the Right Thing, which is for people like that. Even that, not everybody likes. So the thing about, maybe this gets to clickbait, I don't know if it does exactly, but the thing about a lot of science journalists, or at least, I don't know, some of the ones that I know, a totally unrepresentative sample, a lot of us are really frustrated sports writers. So at Retraction Watch, we like our leaderboards. We have a leaderboard of people who have the most retractions. We also have a leaderboard of retracted papers that are cited most often. That one's a little darker, frankly. That one gives me a little more pause. Not that this isn't dark. So we go down to 30. I think it's now at like 32 or 33 because people are tied at the bottom. This is just a screenshot of the top 10. Just keep you awake. Anyone notice anything about the demographics of this list of top 10? Shout it out. Come on. Okay, so this is like not call and response exactly. It's like a round. I hear Japanese men. You're both right. Yeah. So, and frankly, these are both such unrepresentative data points that I hesitate to even mention them, except that I can't help myself because, like I said, I'm a journalist. The from Japan thing, or at least Japanese surnames, it is a real thing. In the sense that, again, out of a highly unrepresentative, that's not a word, right? That's whatever, but you know what I'm talking about, a highly unrepresentative sample, there do seem to be a higher number of people with Japanese surnames on this list. Some of that is because they're actually co-authors of one another. So, and the only reason they're both on there is because we don't include everyone who's on that list. There are some people who should be on this list by numbers, but they weren't responsible, so they're actually not on this list. These are the folks who, they're co-authors in a couple cases. That is one thing, but to me the far more interesting one is that they're all men. And in fact, if you go all the way down to 32 on the list, or whatever we have right now, there's only one woman on the list, and she's pretty low down on the list. So in the interest of equality, egalitarianism, I'm very bothered by this. I would like to see, if anyone can do something about this and help me to have more. No, it's obviously, you can speculate wildly, as people often do, about why this might be the case. Or if it even has any statistical, relevance at all, and by the way, in the next question, the smart one, of course, which I'm sure you're all thinking is, well, isn't it just true that men are overrepresented or women underrepresented, depending on how you look at it, in positions where they would be publishing papers? That is true, but someone actually did that analysis, and they found that even if you controlled for that, men are 9 times more likely to have papers retracted for fraud than women are. So. Yay, men. It's a great thing. I don't know how to explain that, but it's a little bit of popcorn, and there's probably an interesting explanation that I'm not thinking of. But on a little more serious note, so the number one person on the list, Yoshitaka Fuji, was 183 retractions. How many of you work in labs or work with labs that have published at least 183 papers? Anyone? I don't see any hands, actually. So I'm sorry that you'll never get to the top of the list, but we can work together if you want. We can talk afterwards. So this is, I think, an instructive story, and I'm going to get to a couple other sort of sleuths in a minute. Just that's the theme here. So this is a piece that Adam and I wrote in Nautilus several years ago, and it's about Yoshitaka Fuji. It turns out the main player in this story, other than Yoshitaka Fuji, turns out to have had even a much bigger impact than we knew he would, at the time that he would have. And it's really the story of someone named John Carlisle. John Carlisle is an anesthesiology researcher in Actually, he's not a researcher. He's an anesthetist in the UK. He's a practicing anesthesiologist. But he's also a sort of self-trained, self-taught statistician. And so what he has done is looked at lots and lots of studies. He started with Fuji because Fuji's data bothered him. When he would look at the results and he'd look at the papers and the findings, he would say, there's something just not quite right here. They're too perfect. That's what he thought. They were too perfect. And as we all know, when one scientist says to another scientist, your data are beautiful or too perfect, it's not always as positive as it sounds, right? It may be that they have some doubts. So he did something, and I'm going to mangle this, / simplify it, / do all the things that journalists do, but please look up what he actually did because he published it in the peer-reviewed literature. There's something called Benford's law, right, which basically says if there's a variability in biological data, right, that you would expect. And, in a large enough data set, you'll see that variability. When people make up data, they think that they're throwing little, extra data points and sort of outliers and what have you to make it look like real data. They're never as good at that as they think they are. And so Fuji wasn't as good at that as he thought he was. I'm not going to try and explain exactly what Carlisle has done, and it's separate from Benford's law, but that's almost a sort of analogy or a metaphor. He was able to show that the likelihood that these data were real based on the variability that he was seeing was essentially zero. It was like the p-value on when he did the analysis was like 1 × 10 to the minus 32nd, I think it was, or 33rd. Sorry, it's a very important, significant digit, which last time I checked is probably closer to 0 than any of us will actually ever see, right? And so clearly there's something wrong. The interesting thing about Carlisle, though, he didn't stop there. His method also shows whether or not a study was likely properly randomized, right? And so you may have read about a year ago now about a study called the Predimed study, which was about the Mediterranean diet. And so, it was about diet, but it was sort of a little bit more focused on the Mediterranean diet. So there's this massive study published in the New England Journal of Medicine several years ago, and it was supposed to be the first ever randomized controlled trial, because it's very hard to do randomized controlled trials of diets, right? I mean, how do you do that? And so they actually managed to do it, and it was like 11,000 people in this study or something, pretty large, and should have been, and on its surface, was statistically very powerful. But what he was able to show, this is the other thing his method shows, the Carlisle technique shows, is whether or not something was properly randomized. And so he noticed some weirdness in some of the randomizations, right? Or in some of the data showing how people were randomized. And it turns out what he was really uncovering, he didn't know what he was uncovering, but this is what it turned out to be. So there were trials, there were centers all over the world. And so somebody would show up to a particular clinic that was enrolling patients for one of these trials as subject and participants. And you would walk in and say, yes, I'd like to be in this trial. And they'd say, okay, well, we're randomizing you. And you can't really blind people to what diet they're on. I mean, I guess you could blindfold them while they eat, but that wouldn't really work so well. So they would say, okay, you're on Mediterranean diet. And let's say that you walked in, let's say that I had shown up there, and my wife was with me because we were running errands together or whatever, and we're just in the same place. And they say, oh, Ivan, is that, like, do you live with that person? Like, do you eat together and all that? And I mean, we live in New York, so we just order in. But I would say yes. And they said, oh, well, what we should do is, they didn't say it exactly like this, but what they were thinking is what we should do is randomize her if she wants to be in the trial to whatever the next, you get the next number is. But they'd say, well, it's just going to be too difficult because then, you're going to have to cook or order in whatever. Mediterranean, she's going to have to, I don't know, cook, beef, something or other. Oh, why don't you just both go on Mediterranean diet? That's great, except that it's not randomized anymore. So he uncovered that. New England Journal of Medicine study and a lot of others have now been retracted. So keep an eye on John Carlisle, who's an example, really, of, he doesn't call himself this, and you've actually already heard about the guy on the right without maybe knowing that you're hearing about the guy on the right. This is, on the left is, and by the way, this is an homage to Goodfellas, the sort of, and so the scene in the diner, right, with, at the end, Henry Hill and whatever. And they're data thugs, actually. James Heathers, who's on the right, who's behind Just As in Mice. And now I think another one, right? Didn't he just start one? He started another one, I think, just in the last couple days or something. It's already going up the charts. But James Heathers calls them, the two of them, data thugs, as in, you know, that's a really nice data set. It'd be a shame if anything happened to it. Data thugs, right? And so what they have, and we actually had a post up just last week, really just picking up on something that they have been working on, another case. They've worked on a lot of cases. In fact, the next one, which I'll show you, which you'll hear, you've heard of as well. They're good examples like Carlisle. The two of them, like Elizabeth Bick, who we profiled last week for the Scientist magazine, excuse me, of data sleuths, of scientific sleuths who are out there, and there's, by the way, many, many more. We have a list of them on our site, but who are looking for issues in the literature, finding them, alerting journals, alerting, there's a site called PubPeer, where they post a lot of these comments about papers, particularly when it comes to Western blots, these, you know, which many of you may know, of course, are sort of a way to look at proteins, again, oversimplified, but something that tends to get manipulated in the papers that we see that are retracted. And so this is, to get back to this question of, is there more misconduct or are people better at finding it? We're definitely better at finding it thanks to folks like this. And there's a whole interesting, I think, phenomenology, if you will, of who these people are and what they do and how they do it. But one of the cases that they got involved in, they were two of the four people really who were involved, these James and Nick, was the case of Brian Wansink. Okay, now many of you may know about the case of Brian Wansink, really, when you're being precise about it, a food marketing researcher who was often referred to as a food scientist. Let me tell you, though, that he's now gone, but he was at Cornell, or he's about to be gone. He announced his plans to step down. He hasn't stepped down yet. Wansink was in the marketing school, the marketing department. The actual foods, I can assure you that the actual food science department at Cornell, which is where he still is for a little while, always got very upset when anyone referred to him as a food scientist. It's interesting, they didn't get that upset before all this stuff happened, and they were apparently very happy to have him getting headlines about being a Cornell scientist. Maybe not for what I'm about to tell you. So this is and again, I'm going to give you the very shortened version of this. Please look this up, read it. In fact, read the paper that Heathers and Brown, Nick Brown and James Heathers wrote with two other folks, Jordan Anaya and Tim Vanderzee, outlining a lot of issues and a lot of Wansink's papers. That's really the source for all of this, what led to it. And the person, by the way, if you want the sort of journalism version of this, the person who really took this story and ran with it, a lot of us were on it at different points, and we may have technically had the first interview with him, but the person who really ran with it was Stephanie Lee at BuzzFeed. You know, BuzzFeed, if you were still sort of beholden to the notion that BuzzFeed is about, you know, cats and listicles, I'd urge you to take a much more careful look, particularly at the work that Stephanie Lee and others are doing in really important ways there, not just in scientific misconduct, sexual harassment cases. Azim Garashi is doing terrific work there. So this was a piece that, you know, ran in the Times, and, you know, in the spirit of all, you know, all faculty, academics everywhere, I'll just quote myself because, you know, who else knows what I'm talking about. And I won't read this to you, but I just want to point out that Wansink, who now has, I think it's 17 retractions, one of which, by the way, it was a paper, this is a dubious distinction. He's not the only person like this, but we've only had, I think, two others. One of his papers was actually retracted twice. So again, we like our records. It's a short record on that. In terms of the numbers, he's not actually that, you know, impressive. Well, the reason why you read about him in the New York Times and everywhere else is because you had been reading about him and his work in the New York Times. And there's the paragraph from this piece that I didn't include, which maybe I should include instead, is when Anna Had O'Connor, who wrote this piece, interviewing me, he said, after I said to him, you know, I think the only reason that we're sort of hearing about this case and sort of so fixated on this case and acting as if it's the only case of scientific fraud that's ever happened or scientific misconduct that's ever happened is that, you know, everybody quoted him. You know, if you're a health reporter and you didn't quote him, I mean, that's a rare thing. And so he actually went back and looked, and since it was a perspective piece, he could write, oh, I realized I never did, but I got lucky because every one of my colleagues did here at the Times. So, you know, we are amplifying, to get back to this meeting, of course, this workshop, we're amplifying in many cases the wrong messages. We're amplifying the work of people who, it turns out, did not do things well, but we can't sort of say, well, that's the bad apple, that's That's the isolated case. As I showed you, there are a lot more retractions than that, and there are lots of other things that aren't even wrong, right? This idea, and we heard about some of the cases again from our previous speaker, where they sound good, they're like they're candy, they're popcorn, but they turn out they're not even wrong. It's not that you can point to it and say, oh, that study was fraudulent, or was it was done badly, not so much because it was people made up the data or anything like that. It just is completely not generalizable, or it doesn't say what the headlines say it says. And then let me just sort of close with some, again, maybe a little bit darker. I kept tiptoeing around our current political climate, but now I'll just jump right into I'll dive right in. One of the issues that I think that you all face is, whether you're science journalists, science communicators, scientists, et cetera, the other groups represented here, is that these are dangerous issues, according to some people, to talk about now. Now, a lot of us in the room have been talking about these issues long before the current presidential administration. So I feel pretty good saying that, okay, well, maybe people are becoming woke to it now. But in fact, this is something we've been talking about for a while. This was a meeting that happened, again, a couple of years ago. This was at the National Academy of Sciences, and it was planned before the election, and then it happened after the election, and a lot of people were concerned. We're giving ammunition to people who want to doubt science, who want to criticize science, who want to discredit science. And so this is a piece that really, and we actually talked about that case and quoted Marcia McNutt, who was at the time, at the time she was editor of Science, and now she's, of course, president of the National Academy of Sciences, saying, shame on people who would use our sort of approach to trying to improve science and improve reproducibility and improve our record, if you will. Shame on those who would use that to therefore discredit us completely. And that's a sentiment that Adam and I agree with. There's a Washington Post op-ed we wrote just within the last couple of weeks. Some of you may have seen that the Post actually wrote a story about the USDA, a policy that scientists had to now, in all their papers, say, this is preliminary, right? This is a preliminary result. Now, we all know why the USDA wants, and this administration wants people to do that, but they're actually right. That didn't make a lot of people happy, the first half of this headline. By the way, this is one that I definitely wrote and had control over. But they weren't so happy about it. They realized what we were saying, of course, but really have to sort of think about, are you weaponizing transparency? And how do you deal with the fact that when you talk about issues in science and reproducibility, how do you make sure that the message is clear about whether or not that's true? So again, very quickly, one of the other concerns, and this has been true long before the Trump administration, with Retraction Watch, people have said, well, you're sort of airing science's dirty laundry. You're concerned about that. And I want to be upfront about, we've definitely had these conversations. And we had nothing to do with this study, and this has been replicated twice by other work since then. But what this study found, and again, I won't read this to you, and I'll zoom through this in just a minute, but what happens when you retract a paper for a bad reason, so for misconduct, fraud, et cetera, something that's considered a bad reason, obviously, is that you see a decline in your citations. In fact, your whole field sees a decline in its citations, so you're actually messing it up for everyone. But so that's what you would expect, and that's the stigma that's attached to retractions. But what's really interesting is that when you retract a paper for honest error, and the retraction notice is clear about that, you don't see a decline in your citations. And again, not that citations should be, but they end up being one of the important coins of the realm in terms of science, in terms of getting ahead in science and career progression. So we think this is a good message. This is a good sort of sense of things, and I'll just wrap up here. I'm not even going to go through these, but I'll just tell you, and again, I can make the slides available. How does this translate into the science journalism or the science press releases, or just the science communication that various people in this room do? These two studies, which I'll end there, and you'll have to trust me on it, but you don't have to trust me on it. You can go and read the studies, and again, I'll make the citations available. What these two studies, they're pretty small, I want to be clear about that, say is that actually when you ask readers and when you see about, when you test their comprehension of what a paper actually said or what a story says, they trust it much more when you talk about the uncertainty that's involved. They actually, yes, we can clickbait may get them to the story, but when you actually talk about, and you can talk about, for example, the Health News Review criteria for what should go into a story about a medical study or about a clinical trial, they actually trust the story much more if there is nuance and if there is, uncertainty in it. Again, just 2 studies, I don't want to overstate the case, but I hope that it at least prompts some thinking about whether or not we can be a little more, frankly, honest and transparent with our readers, with our viewers, with our listeners, based on some of that and based on what we all, I know, want to do, which is tell the real story of science. So thank you, and happy to take any questions as we have time.
We have time for one question. Does somebody have a question? I think I can speak about it.
I can repeat it, Crystal.
What are some practices we could take in our own press offices or news outlets if we've reported on a study that has been retracted to kind of correct the record so it doesn't live online forever?
Sure, that's a great question. So the question, how do you deal if in a press office if you've sent, if a paper from your institution or one that you've sent out a press release about in the past has been retracted? We, at a base, and actually Nature Publishing Group agrees with us on this. They don't agree with us on a lot of things, but they agree with us on that. Whatever you did for this study, whatever you did for that finding, or whatever the phenomenon, whatever the issue, whatever the story was, you should do for the retraction. So if you've put out a press release on Eureka Alert or wherever it is, put out a press release about the retraction. It's not the most fun day you're going to have, but put out a press release. Frankly, we think that there should be some triggers, though, that aren't just whether or not you put out a press release. There are a lot of studies that don't get press released, or maybe you only, you gave it to a couple people who are interested. But if you look at and I'm not a big fan of altmetrics as a metric. Like, I think the metrics part is a little bit misleading. But all of you know the altmetrics, right? So if you don't, you go to any paper now and you see that like sort of rainbow circle thing with a number in the middle of it. The higher that number, the more times it's been mentioned, in the media, on Twitter, social media, et cetera. I would argue that if it has a reasonably high altmetric score, or you just see that lots of people have tweeted about this paper, correct the record. I mean, get it out there. The uncomfortable fact is that when we write about something, it actually gives you a really high altmetric score, which is one of the reasons why I don't think altmetrics is a very good demonstration of impact, because you're demonstrating it was false if we're writing about it. But I would argue that at least whatever you did for the study you should do, and have some sort of conservative, if you will, or liberal, maybe depending on how you look at it, permissive sort of approach to getting the word out about something even if it wasn't press released. Thank you. Thank you.
Thank you. Thank you, Ivan. Here comes that term, fake news. But along with it comes some context. Our next session is called The Science of Fake News, Recognizing and Eliminating Misinformation and Disinformation. Leading us is Dr. Nicole Cook. Her recent book is described as a call for the public to acquire appropriate research and evaluation skills and to become more information savvy. Nicole is an associate professor in the School of Information Sciences here at the University of Illinois at Urbana-Champaign. She directs a program that leads to the Masters of Science in Library and Information Science. Her research and teaching interests include human information behavior, particularly in an online context. She emphasizes cultural information studies, diversity, and social justice in librarianship. She accentuates those topics in information science education. She received the American Library Association's Equality Award in 2016, and in 2017, the ALA's Achievement in Library Diversity Research Award. Please welcome Professor Nicole Cook.
So, good morning. Glad to be here with you all, and thank you to Diana and the committee for the invitation to come chat with you today. So, I feel like I should make a disclaimer right up front and tell you I am not a scientist. I am a librarian, and shameless plug, the librarians can be your best friend in the work that you do. We have lots of great science librarians, applied health sciences librarians, even your public librarian can help in the work that you do and help us eliminate some of this fake news. So I just want to get started with a few concepts. So as you heard in the introduction, some of the work that I do is related to information behavior. And I usually, in a nutshell, say that information behavior is how people use, seek, and avoid information. And as part of that, we talk about how people interact and are essentially susceptible to fake news. And one of the reasons that people are susceptible to fake news is because of emotions. We are humans, we are complicated beings, and we encounter and interpret and use information in very different ways. And so, you know, there is a dimension of perhaps intellectual laziness involved, but there are so many dimensions and so many reasons that people are susceptible to fake news. And so again, one of them is emotions, and that's what we'll talk a little bit about today. So it is said that we now live in an era of post-truth. All right, and so just as a kind of to back up just a second, fake news is not new. There are accounts of the phrase fake news being used as early as the 1890s in print newspapers and media. And actually, post-truth is not new. Stephen Colbert talked to us almost over a decade ago about truthiness. And truthiness and post-truth, we'll use them interchangeably, really talking about this idea that we are believing information based on our guts. We are believing and accepting and using information, sharing information based on our hearts, based on our beliefs, not because that we actually think it's factually true. And so what becomes especially tricky about fake news is that intellectually, cognitively, I can know that that article is garbage, but maybe I like the author. Maybe I like that particular source. Maybe someone that I trust forwarded it to me, and therefore I'm gonna go with my gut and say, oh, well, you know, Kate wouldn't send me garbage, right? So I'm gonna believe this article. All right, so this is this idea of post-truth. We are leading with our guts, and we're not taking the time to go back into our critical thinking, what a lot of us are trained in about, you know, how to critically evaluate and use information. We're not going back to our default. All right, and as you heard in the previous presentation, you know, this is particularly heightened with our political climate and things of that nature. So as a librarian, I've been working in what we call information literacy for 20 years. And information literacy is really just teaching people how to critically evaluate and use information. After the last presidential election, I started getting phone calls and emails. Oh my God, fake news, this crisis, what are we gonna do? And my reaction was like, what are you talking about? With this idea that we've always had fake news, we just called it something different. Okay. So when we talk about fake news and we want to bring it into larger context, fake news is essentially a form of misinformation. And so very simply put, misinformation is information that is false. It's misleading, but it may not be purposely designed to be false or misleading. So if you remember the game that we played as kids as telephone, right? And you know, if I tell someone something in this part of the auditorium, and then they whisper it across the auditorium, by the time it gets to the other side, the message could be completely misconstrued. It can be completely different. Now, that doesn't mean that there was any ill intent. It just means that people are people. We hear things the way we want to hear them. And by the time we pass that information on, it could be false. So when we're talking about information that we're sharing, particularly online, I think maybe all could admit to sharing information that we have not read, or that we have not clicked on the link to actually read the article. All right, so the speed with which information is shared, and this is why misinformation, disinformation, which I'll talk about in just a second, and fake news become really so problematic, right? Because they're moving with such speed, it's hard to get things back. And at this point, we're just inundated with information and fake news. All right, so misinformation, information that is false. Now, its sibling is disinformation. Disinformation is information that is also false, but is also purposely created to be false. It is purposely created to mislead and to actually harm. Okay, so this is what you're hearing about this morning. This is what you'll hear about in some other sessions. There are people whose job it is to create clickbait and false information, disinformation. All right, so it's part of what we call political economy. This idea that this is for profit. So there are a lot of folks, as much work as we do to combat misinformation, disinformation, fake news, there are people that actually work in cubicle farms whose job it is to pump out fake information because they want you to view their website. Okay, so that would be disinformation, information that is purposely created to mislead or harm. There is a third category called malinformation, M-A-L, and that is also disinformation, false information that is purposely created to harm or mislead. But when you think of things like revenge porn or doxing or things that are really, really harmful and could actually be criminal, so then we come into an even darker third category of malinformation. And fake news also falls into that category. Lots of different reasons, in addition to the emotional dimension about why people are susceptible to fake news. One of them is confirmation bias. And confirmation bias is this idea that you will seek and use information that already confirms what you know, right? So if you tend to look at particular sources because you like those particular authors, or it has a particular political leaning or other leaning that you subscribe to, you might be more inclined to just use that source because it confirms what you already know. All right, so you see this a lot in partisan politics and other types of news sources. This could also be discussed as a filter bubble. All right, if you're on social media, whatever platform that you're using, you could go all day, you could go a week and not see any information that contradicts what you know or believe, right? We are able to so carefully curate our feeds, our friends, what we see and what we interact with. It is very possible to really just give in to confirmation bias and or filter bubbles. Another problem that we have is information overload. And this is not exclusive to fake news or misinformation or disinformation. Information overload we have every day of our lives. So as we go through our day and you decide what you're going to wear, what you're going to eat, how you're going to drive to campus, there are so many pieces of information that we just absorb and don't even really think about or we're not even cognizant of how we're interacting with that information. Some information we choose to use, right? If you see that there's a detour or something, you might actively use that information to reroute. There's other information that we absorb and just immediately dismiss, right? We all have our mental frameworks for how we use and avoid information. So when we have information overload and we have fake news and misinformation and disinformation coming at us from print sources, from radio, if you're still listening to radio, podcasts, the internet, we have information coming at us from every angle at all points of the day. All right, and so this can contribute to this idea of, I'm just so overwhelmed, I'm just gonna pick the first website that comes up. Or I'm just gonna listen to this one story and I'm gonna get all my news for the week because I'm just so overwhelmed, I can't take it, and I'm just gonna pick something that's easy, something that I can subscribe to and that will let me know what I need to know. So different responses to information overload. But if we're not careful about the information overload and really critically thinking about what we're absorbing, we can be more susceptible to fake news, misinformation, and disinformation. Another dimension is cognitive authority. And cognitive authority is essentially, who do I believe? Right? And so your cognitive authority you can assign to other people, you can assign to other organizations, you can assign it and revoke it at will, right? This is really how you think about information and how you decide who you're going to trust for the information that you use. All right, so as an example, my mother is a registered nurse, right? So I give her all of my cognitive authority when I have a health question. You know, how do I know if I have a cold? What should I take? That kind of thing. Now, you know, she's not a particularly good gardener, right? So she might not be my cognitive authority for gardening, right? I may have someone else that I ask, you know, it's planting season, what should I put in the garden, right? Maybe I have one cognitive authority for flowers and I have a different cognitive authority for perennials, right? So cognitive authority is very layered, it's nuanced, we don't always think about it, but it is. Now, in terms of revoking that cognitive authority, if I go to a friend's house that is my cognitive authority in gardening and I see that yard is a mess, I may revoke cognitive authority. All right, so particularly for those who provide information and communicate with others, these are some of the things that we need to think about when we're providing information to others, right? Your information can be spot on, it could be perfectly researched, but if someone doesn't give you cognitive authority, or if they're overwhelmed, or if they're just cranky that day, they may not be receptive to what you're putting out, right? And so there isn't necessarily a rhyme or reason to it, and there really isn't necessarily anything you can do about it. It's just context that you need to have when you're preparing information to give out to other folks. And part of this trust is very much related to this cognitive authority. Who do I trust? And how do people come to decide what sources they trust for their news information, their science information, any other information that they are consuming? You'll always hear people say, I don't watch that channel, or I only watch this channel, I don't listen to that person, you know, I don't read this particular paper. People have very clear ideas about what sources they trust and mistrust. Now, depending on, you know, how much a person is really thinking about it, how much they discuss it, they might actually be able to tell you, this is why I trust this person, or this is why I don't trust that person. But perhaps the average person, if you ask them, why don't you watch this channel? You may get something like, I don't like that person, or I don't like what they're saying. But they might not have a really nuanced explanation for why they trust and not mistrust. So again, going back to the beginning with post-truth, they trust because their gut tells them to trust, or they distrust because their gut says, yeah, I don't like that. Okay? So let me show you two things. Just give you a second. All right, are we seeing the distinction between the two? All right, so this is essentially post-truth, right? This is us looking and evaluating information with our gut. So I'll see it. You can show me all the evidence you want. You can show me all the data you want. But if I don't trust you, or if I don't subscribe to what you're saying, or if there's any type of discrepancy here, I'm just not going to believe it. I could see it, but I'm just not going to believe it. All right, so let me give you a couple of examples. And so the examples are really, going along with this idea that we have emotional reactions to information. All right, so you as a science writer, as a communicator, you could give me a story this morning, and if I'm in a good mood and the coffee was good outside and, I saw a couple people that I know, I'm all for your article. All right, and yes, this is excellent. I'm going to share it with my students, etc. Now, if you catch me at 5 o'clock and I'm sleepy and there's traffic and I don't know what I'm cooking for dinner, or I just got a text from someone that had bad news, you could give me the same article or tell me the same information and I will receive it completely differently, right? Because of my own emotional state. All right. So again, this is information and context that we need to be aware of with our readers, and also, for ourselves. How are we interpreting information when we are trying to then write about it, or then research about it, or then provide it to other people? All right. So a couple of examples. On the left-hand side, this particular example. I don't know if you can see it, but at the very top in really, really tiny writing, it says that this is an advertisement. Okay, but what you see is that very large headline, "New pill reverses memory loss in an amazing way." And so you see this in newspapers, you see this in magazines, you certainly see it online. And you'll see a lot of literature that says, fake news, seniors and older adults are most susceptible to fake news, which is not necessarily true. But this is the type of information that is purposely targeted at seniors, right? So they're particularly susceptible to health information because they may have some other health issues. They're always looking for new information to see if they can find a cure or a solution or something. And so really what they're trying to do at the end of this article is to sell a particular product. And so again, you're looking at that headline, you may not see advertisement. It's very similar to when you go to Google and you do a search, and like the first 5 hits or so are usually sponsored ads, right? So sometimes we're not always paying attention to that. So this is an older print example of that, if you will. The other thing that I don't think you can see in this article is that under the little abstract, there is an author's name, Daniel Ward Sr., and his byline is listed as the Associated Health Press. There is no such thing as the Associated Health Press. So what it's relying on is your recognition of the Associated Press, right? So we know that that's a source. We're familiar with that source. We know that they put out short stories and they're syndicated and things of that nature. So when we're doing the critical evaluation, the people who are coming up with this type of information, they know that you rely on visual cues and oral cues and cues that are related to things that you may already know and trust. On the right-hand side, very provocative title. All right, and so that is one of the cues. If you see a title that is in all caps, or if you see a title that is excessively flowery or absolute, that could be, a cue that, something is amiss here. And so what these examples are giving you are fake experts. All right, so on the right-hand side, this was an article that came out in 2017 that claimed that this data was brand new and revolutionary. And it was actually based on an academic article from 2010 that said nothing of the sort. So in this brand new, groundbreaking article, women absorb and retain DNA from every man they have sex with. In actuality, what they were saying is that in autopsy results, women had male chromosomes in their bloodstream. Now, that could have happened because they had a male child, they had a male sibling, particularly a twin, or they could have had a blood transfusion, right? So we have this thing where it's based on science, it's based on, hopefully, an article that's not been retracted, and it's spun years later into something that's salacious and will hopefully get a click or a purchase or something of that nature. All right, so when we have articles like this, and particularly if they can reference what sounds like an academic journal, right, that's one of those cues that people have to say, oh, well, it cites an academic journal. And we know there's no bad academic journal, there's no bad academic article. right? So people are relying again on, I'll get by on association, even though that association is manufactured. Okay. Misinformation and misinformation and disinformation, particularly as it comes to health and scientific information. So this is Ethan Lindenberger, and he is a high school senior from Connecticut, and he made some news last fall because he testified in front of the Senate after he made headlines for getting vaccines at the age of 18. And so he explicitly went against his parents' beliefs and wishes. His parents did not believe in vaccines, and he and his siblings were not vaccinated. And so he came to do his own research, and he decided that he was at risk and he was going to go ahead and get vaccinated. And because he was 18, he was able to do that. And so in his explanations, he talked a lot about, if you follow the story, you can see that he polished it up a little bit. But in the beginning, he said, he actually said his parents were stupid for, believing this. But he evolved after he hurt his mother's feelings, but really said that she was susceptible to a lot of conspiracy theories, fake news, misinformation, and disinformation. And he explicitly blamed Facebook. All right, who doesn't blame Facebook? But you have a lot of groups, and you have the news and the articles and things that are spreading so quickly. His mother believed that the vaccines would cause autism and other health problems, and she decided not to vaccinate her children. So in a subsequent interview, she did admit, reluctantly, that she read all of the research that he had compiled, and she actually saw the benefit in what he was saying. She still wasn't going to vaccinate her younger children. All right, again, she saw all the evidence and she could admit that she believed it, but she still wasn't going to change her mind about what was best for her children. Okay, and certainly that is her prerogative. Now, there was a story on the news that I saw this morning as I was coming, so I couldn't update my slide for you. We all know that there's a current measles outbreak in different parts of the country. And in New York, the epicenter is in Rockland County, New York, which has a predominantly Orthodox Jewish population. And so this report was fascinating. I actually sat there with my jaw dropped open. They displayed a paper pamphlet that has for years been passed around this particular community. And the Orthodox Jewish parents are not vaccinating their children. This is currently the epicenter for the measles outbreak in New York in that region. And when they're asking people, why are you not vaccinating your children? And the parents are citing this pamphlet. And the investigators, were looking at this pamphlet. They were calling the phone numbers that were associated, for contact information, because that is one of the things that we're taught to look for. When we're looking at a piece of information, does it have a source? Is there someone we can contact? Is there something we can look at, further? And so they did all of that. The addresses went to vacant warehouses, because they actually went to the address on the pamphlet. The phone numbers went to recordings, untraceable recordings, and the recordings said that all vaccines cause encephalitis and autism, and that you shouldn't vaccinate your children. So there was no actual live person to talk to and try and confirm or deny this information in the pamphlet. And what they also found was that the Jewish population, when they would go to synagogue, there were perfectly timed texts coming to these folks saying, don't vaccinate your children and please call this number. And the number would link back to one of those recordings. So when we're dealing with misinformation and disinformation, the folks producing this are very organized and they're very strategic, right? So, when I do the work that I do in the School of Information Sciences, we talk a lot about being strategic and being proactive in evaluating this information because the producers are outpacing us in that regard. Okay, So celebrity culture. And this is Jenny McCarthy, an actress who, for a lot of people who also believe that vaccinations are harmful, will cite Jenny McCarthy. Now, I don't know why anybody would cite Jenny McCarthy for particularly health information, but we can attribute some of this to celebrity culture, right? I mean, for decades, celebrities have been pitching us products, infomercials, commercials, product placements, all of these things. And so this is just the latest example of this. And so she has a son. Her son might be a teenager at this point. And she felt that his autism was caused because of his vaccines. And so for several years, she had a lot of press. She did a lot of interviews saying, don't vaccinate your children. I regret vaccinating my son. Now, at some point, she did actually retract that. But as you heard in some of the previous sessions, by the time those retractions come out, we have moved so far past this, you probably don't even know that she retracted it. And if you were to look her up and look up Jenny McCarthy and autism, you're going to see her previous claims. Okay? And as a side note, since we're talking about media and communication, this kind of thing, when we're writing things up and when we're presenting information to other people, we could write a neutral story, one that is fact-based and well-researched. But if you put a picture up like this, that could demonstrate a little bias, right? So when I was looking for pictures of her, this was an article that was trashing her about a movie, not necessarily about her political views. There are lots of other pictures of her where she has her glasses on and her hair pulled back and she, looks a little bit more astute than she does in this particular picture, right? So this idea of how we are acquiring information, it is not just from print, it is also from pictures, right? It's also from other information that could accompany the stories that you're writing. Another example of celebrity culture. Does anyone know who this is? Okay, thank you. Yes, so this is Selma Blair, another actress, perhaps not as well known. Movie actress, 90s, 2000-ish, teen movies, types of things. At this year's Golden Globes, she arrived at a party in this very spectacular dress and, in a very posed picture. And the headline was, Selma Blair reveals that she has MS, multiple sclerosis. All right? And so the picture, you can see at the side, she has a walking stick or a cane. All right? And so she was using this opportunity and has done subsequently several interviews detailing her health and how she feels like it was going to impact her career, et cetera, et cetera. So in this particular instance, it appears at this moment that she is using her celebrity to promote good information as opposed to misinformation and disinformation. All right, so different examples of the celebrity culture. Now, what wound up happening is that she acquired a whole new fan base. So, there's some strategic celebrity things happening here. I won't watch her movies still, but I might check her out on Instagram to see how she's doing. All right, so she is bringing awareness to a very serious medical issue. So you had one example of celebrity culture run amok. You have another example of it at this point being used to benefit others. So I have a couple more examples for you about misinformation, disinformation, specifically as it relates to health and wellness and science. But if we're talking about larger context, unfortunately, we can never get away from other issues like race and ethics and things of that nature. There's lots of discussions in my particular profession about, libraries are neutral and information is neutral. There really is no neutral information. All right, so when we're making our decisions about the information that we consume and share, we do need to be keeping ethics, race, and lots of other issues in mind. So this is Caster Semenya, who is a South African runner, perhaps one of the fastest women that we've ever seen in the sport. Caster Semenya has been in the news of late because essentially the authorities in the sporting world have said she's too fast and she's threatening the men and she's winning over the men. And because, you know, when we're talking about sports, only the men, and usually only the white men, can be the fastest and win the most awards. So Caster Semenya has a hormone imbalance, which I can assure you the women in this room can tell you is not uncommon. So she has a higher level of testosterone, which makes her a little bit faster. So the authorities have said to her, if you want to continue to compete, you must take a drug that will lower your testosterone because you have an unfair advantage over the other women that you're competing against. But they told her she could run with the men. So she lost her appeal. It remains to be seen if she will continue. She said she will not take the drugs. I can't say that I blame her for that. But what I wanted to get to is that this is a screenshot from Fox News. And this was the headline that they ran. Transgender runner loses court appeal. Caster Semenya is not transgender. She has high levels of testosterone. So this is what we call dog whistling. It really is just racism, but it's dog whistling, right? So you're putting out a concept or a term that you know is going to incite or inflame or upset. All right, and so when you click on the article, they're talking and they're actually lying about this runner. And then further down, they link to another story where they were talking about a trans wrestler. And that story was equally egregious. And then the article devolves into, you know, this is a moral issue. And it really does turn homophobic and transphobic. All right, so this was meant to kind of incite, all right, even if it was then talking about some of the actual medical or scientific issues, it was meant to essentially inflame, and then it moves people away from the issues. Okay. Two more examples for you. On the left-hand side, the headline, Black moms are dying at higher rates. Kamala Harris, Elizabeth Warren call for change. So the reason I wanted to give this particular example, Black moms are dying at higher rates. What I found interesting about this was how many non-Black people that I spoke to after these rallies and people, you know, Kamala and Elizabeth were talking about it and said, did you hear that Black mothers have a higher mortality rate? And this was brand new information for a lot of people, when in fact this has been happening for I don't know how many decades, okay? So when you're hearing this idea of amplifying the signal, why aren't we hearing more about this? We heard from Serena Williams, all right? Famous Serena Williams, arguably one of the greatest tennis players, if not the greatest tennis player of our time, and has an enormous amount of money. She came out and said that she almost died after childbirth because of complications and because of her doctors and providers not believing that there was something wrong, right? So if you're thinking about various types of privilege, and this woman has as much money as she needs, and she still can't get the care that she requires. And so there's literature that says the medical community thinks that Black people and other minorities don't feel pain, or that they don't feel pain as much as others. So they're reluctant to provide drugs and treatment because they think that the women are being dramatic, or that they're not really, they just want drugs, okay? So to say, these are examples of stories and issues that deserve amplification. All right, in 2019, it was amazing to me that someone would say, I had no idea about this, okay? Now, on the right-hand side, this was just bizarre to me, but it happened. All right, so this is Abby. Abby is a sea otter at the Monterey Bay Aquarium. Abby's a little chunky. We don't pick on Abby. Abby is happy. That's all I care about. So the aquarium put this out on social media, and by all accounts, they were probably attempting to be funny. A lot of people did not find the captioning funny. What is happening here in this caption is a use of African American vernacular English. All right, and some thought that the captioning was insensitive and that it was culturally appropriating Black English, and they took offense to it. And so there is a lot of tweeting happening at the aquarium saying, really? Right, there was no better way for you to talk about Abby than to call her thick and you know, all of these things. And so what wound up happening, amongst other things, is there was an article written up in the Sacramento Bee, and the article, and I use that word loosely, was really just a compilation of tweets. And the author wound up taking tweets from an African-American woman, a scientist, a well-known, regarded scientist, who was particularly critical. The writer took her tweets and then became critical of her. So it no longer became about Abby. And so this woman, this African-American scientist, was trolled and threatened and doxxed and all of these things. And so this is, you know, an example of where ethics come in. All right, so on different levels. Her tweets were used without permission. She was not contacted for comment. She didn't even know what was happening until she started getting all of the mentions. All right, and this writer wound up putting her at risk. And for what? All right, so, and I should also mention that there were lots of other scientists of all races, creeds, et cetera, who were complaining about this post. Their tweets weren't used. You know, they were not put in harm's way. All right, so, you know, ethical concerns about how we are using information, and then, you know, how this then becomes misinformation and disinformation when we cherry pick facts or cherry pick different details and target certain people to say, oh, well, look, you know, this Black woman has a complaint, and this Black woman hates Abby the sea otter, right? Which is nothing about what she said. All right, so these two examples are really good examples of stereotype threat. All right, and so we all have implicit biases, we all have stereotypes, and you know, the stereotype threat that this represents is that what I mentioned earlier is that Black women don't feel pain. That is a stereotype threat in terms of how the medical community may interact with this population. Stereotype threat saying that, you know, Abby is ghetto because they're using African American vernacular English. All right, so different things to think about, not only when you're reading information in headlines, but when you're producing them as well. So I just want to end again with this idea of strategic amplification versus strategic silence, right? So that becomes particularly important when we're talking about misinformation and disinformation, because you all have a lot of power if you're putting out your stories and your pieces that are received by an audience. So strategic amplification, are there worthwhile stories and people that you can highlight? And are there people and stories that you should probably not give any more attention to? All right, so unfortunately, you know, we have a lot of mass shootings, and what we've been seeing lately is reporters saying, I refuse to name the person that shot these people today, right? That is an example of strategic silence. Instead, I'm going to name the people who lost their lives or who were injured, or the people who demonstrated heroism and really tried to assist. That is strategic amplification, all right? So, you know, it becomes difficult because, you know, there is a monetary bottom line. You know, we talked about political economy, and you have to sell papers or you have to get subscribers, and there's always some type of number that underlies, you know, the industry, you know, that we're in. But is there more responsibility that we can take? are there more ethics that we can consider when we do the work we do, so we don't contribute to the consistent problem of fake news, misinformation, and disinformation. I am hoping that the phrase fake news will go away shortly, but the actual phenomenon will never go away. We'll just call it something else. All right, but there are ways in the work that we do that we can hopefully work against it and combat it. So thank you so much for your time, and I think we have a few minutes for questions.
If you want the term fake news to go away, what term would you suggest?
Yeah, so if I want fake news to go away, what do I want to use? I really just want to use misinformation and disinformation. I think part of the problem that we have is that fake news has essentially been co-opted, and it's used to just rebuke and say, I don't like that, so I don't want you to pay attention to it. Fake news, and it loses its actual meaning. So I think misinformation and disinformation better encompasses the actual phenomenon. Yes.
For those of us in writing roles, communication roles, a lot of times you want to just stick within what you're covering because you want to have that trust that you were talking
Right.
about. Like, this is the brand that you can trust us with. This is the kind of stuff you come to us for. But when we come across situations where, I know you mentioned it earlier, where you say, why aren't we hearing more about this? Sometimes that's a result of people selectively sectioning out into their own little information
Sure.
ecosystems. I guess, what are your thoughts on balancing us trying to get into those outside ecosystems to share those kinds of facts versus staying true to the kinds of information that we are trying to be known for? Sorry if that didn't make any sense.
No, it does, but it's a hard question. So if you didn't hear the question, it's essentially about how do you balance the information that you're known for or that perhaps you're charged with covering versus other stories that you think might deserve amplification or coverage. Does that?
Kind of, yeah. Or when people come at you with the attitudes of why aren't they hearing more about this, how much commentary or how much time and effort do you want to spend on commenting on that kind of thing? And
Okay,
encouraging people
okay.
to select it,
Yeah,
sort of
yeah.
consumers of information versus just going back to
So how do you redirect them?
right.
Yeah. So I think maybe the easiest way, and easiest, at least in my mind, is can you refer them to a source that you trust that might be covering that particular issue, right? Because I agree with you, not one person or entity or source can do all of the things, right? But maybe there's another source, or maybe there's another organization or another person who could shed some expert commentary on that topic, right? And then that becomes perhaps another way to generate trust, because you're telling the person that hopefully trusts you, well, this is a source and a person that I trust that might have some more information, that to suit your particular question. I saw a series of tweets yesterday, and I didn't get a chance to, dig deep into it. There was something on NPR that folks disagreed with, and folks actually tagged Code Switch, which is one of NPR's podcasts, and said, "Are you going to let this stand?" And the Code Switch people got a little cranky. And I understood why they were being cranky. They said, so you want us to essentially go to our colleagues in another building who are on another beat and who have a completely different editorial, responsibility, and you want us to go correct that information. And so it got a little heated in the exchange. And the original poster said, no, I don't want you to correct it. I want you to talk about it. And I want you to talk about why this was particularly false, or how to go about it. So that reminded me of your question, because I think that puts them in a difficult position, because they literally knew nothing about it, right? But now someone else is coming to them saying, well, you're NPR too. And it's like, but you don't understand the branches of the organization. So again, lots of layers. I agree with what you're saying. And so I think what Code Switch could have done was say, this is not really our area, but maybe it's somebody else's area to address, the concerns that you have about the particular piece.
How easy is it to draw the line, or do you have guidelines to draw the line between, making sure information products are reliable and, concepts like censorship or infringing on, people's right to free speech, things like that?
Another shameless plug for your librarian, because this is literally what we talk about all the time. There is that fine line between, hate speech, free speech, et cetera, but it is also that idea that free speech doesn't mean that you're free from consequences. You'll go in a library and find information that you despise, right? But because it may appeal to someone else, we keep it there, right? So we're about information access, things of that nature. Not saying that information is neutral, but saying that you don't have the right to steal the book or tell us we can't have the book if someone else could use it, right? So there is that fine line, and I think that's where the trust and the communication comes in between the information provider and the information consumer. So I'm giving you a very, top level, but to say that we do talk about this all of the time. But, and that would also go to that line between misinformation and disinformation, right? So misinformation, it could just be as easy as I didn't hear you. And then I repeated what you said, and that's not really what you said. But the disinformation, and this is where we get into different intentions, which are sometimes hard to discern. If this person is purposely trying to trip you up or to harm you, then I think that's the area where we need to say, is there something that we can do about this? Now, someone else asked me about, at another talk, should the government get involved? And at this point, I don't want the government to get involved in anything. Because I think it's a slippery slope about what could be regulated and what couldn't be, right? And this is when, sometimes people will say, oh, well, I created this browser app that will identify fake news. That's cool, but I think we still have to primarily be manually interacting with the information that concerns us. So again, it's a tricky question about how do you kind of decipher that, but I think it's going to be that trust and discussion and really kind of getting into the evaluation as opposed to kind of that post-truth, knee-jerk, looking at headlines, oh, I'm going to share that, oh, I'm going to click on that, oh, I don't like that, and you don't really have all of the context. Yes? Thank you.
Navigating a tension between two different principles as a journalist. So one is appreciating that, as you say, there is a certain ethical responsibility in quoting people's tweets, that women, people of color, and especially women of color, are more likely to experience harassment, doxing, all the rest, when you're quoting them in the context of topics that may be controversial. But equally, I think as a journalist, we all feel that things that are written on social media are in the public domain. And to take a very extreme example, I would not be reaching out to Donald Trump for permission to discuss Donald Trump's tweets. What are your thoughts on how to deal with that tension between on the one hand, wanting to recognize that some sources are disproportionately harmful, but also that there are these sort of universal guidelines about what is and is not in the public domain?
Yeah, sure. Thank you for that. My first thought to that is that Trump is a known figure, a public figure. He wants you to, engage with his tweets and things of that nature. I think there's a difference between Trump and, faculty members here at the U of I, or anywhere, really, So we have these discussions about whether or not we are public intellectuals. Now, I have had people tell me that I am a public intellectual. I actually push back on that. And as a consequence, I have locked down all of my social media because I have been trolled and doxxed and all of these things. So I think there's a balance, right? So if you have public intellectuals who are writing op-ed pieces or who are writing in mainstream media as opposed to the peer-reviewed journals, those are the folks that are more on the public intellectual side. Now, with that said, for something like the Abbey incident, I think a more even representation of the tweets may have derailed all of the problems that the woman encountered, right? And then, you know, if this reporter was adamant about just focusing on her, he could have tweeted her, right? Maybe she didn't answer, maybe he didn't, or you know, what have you. But I think there was some due diligence that was completely lost. And it really came out as a hit piece because it was just her comments, right? So with this particular example, there were hundreds of tweets. He could have picked one from her, he could have picked one from this wide array, but to focus on her, I think that's where perhaps he crossed that particular line and made her more vulnerable than she already was. But I appreciate what you're saying and agree with you about, you know, what's out there as public. You know, we're engaging with this public information. Yeah, okay, yes.
Do you have any thoughts about what scientists should do if one of their stories is sort of spun into these misinformation pieces? Like, is there a responsibility to push back on that, or does that just draw more attention to it and hurt things further?
All of the above. And this is me speaking from experience, having my work, and I was like, I didn't say that. I was like, what? To a certain extent, there isn't a whole lot you can do. I mean, unless you are the editor and you can personally retract it. You know, I've known people that would go to the editors and say, you know, can you put out a retraction? And sometimes that happens. Sometimes it doesn't. And then you have to figure how much emotional labor you want to put into that if you want to fight that fight. Sometimes it's worth it, maybe sometimes it's not. But I mean, all you can do is say, absolutely, that's not what I said. But I've known other people who have written in other places and said, let me tell you about this source that twisted my work, and I'm going to tell you what I really meant. All right, so there are various ways, I think, to kind of go around that. Yes.
Could I just put out a shout out to our news bureau if you're here at the University of Illinois, because I have experienced this, and I called the news bureau and I said, advice, help.
Mm-hmm.
Advice and the help I got was unbelievably valuable. It made all the difference in the world. Really, we have folks here at the university who know what they're doing, and they'll help you.
And on that note, thank you all.
Thank you very much, Nicole. I'm here with news about lunch. You have 3 options of where to eat your lunch. You may go outside, you may sit in the room across the hallway from the auditorium, or you may take your lunch to the tables in the atrium that are marked reserved. Beckman also has a lunch cafe, and the tables nearest the cafe are for the cafe people who are coming and getting their lunches. Your lunch is supplied, and you may sit at the tables that are marked reserved. If you ordered a special meal, you had a special food request, those lunches should be marked with your name. So if you don't see your name, please ask. And we hope you enjoy your lunches. We will resume at 1:05 right here. Thank you.